Now let's just jump straight into the code. So first of all, we're going to be working in this main.py file. We'll come to the others later on, but we begin with this main.py. And the first thing we want to do is actually import the pygame module. Now, once the module is imported, we need to initialize it. And that's done by saying pygame.init. The next thing I want to do is create a game window where the
muchas ideas. Por ahí estaría pronta la instalación. Tutorial, muchas ideas, muchos proyectos ya. Voy a importar sys también, que es la cual va a ir a. Ahí vamos a. A que bien, le damos enter, esperamos un poquito. Ahí está diciendo, lo está descargando la versión, en este caso 2.1.2. Obviamente cuando ustedes vean esto la versión puede cambiar, pero el procedimiento es exactamente el mismo. Así que bueno, ahí dice el paquete está siendo instalado. Así que nada, esperar un poquito hasta que culmine la instalación. Y después, bueno, vamos a entrar a su line text y vamos a probar a ver si realmente está funcionando.
Seguir viendo también lo que es lo que es Python, como verán, es donde voy a borrar acá esta carpeta que dice program file y solo dejo así donde está Python. Vamos a poner import y acá la vamos a poner pygame. En este caso yo, como esto no me deja lo que es accesos directo, entonces yo voy a ver acá donde se me instaló o donde están mis programas y le voy a dar en abrir ubicación para poder copiar lo que es el ID acá en lo que es mi escritorio. Lo copio y lo pego acá en mi escritorio. Y ahora vamos a abrir esto. Vamos a hacer una pequeña prueba. Entonces, como verán, vamos acá y vamos a un Wi-Fi y acá vamos a poner import y acá la vamos a poner pygame para que vean que no tengo lo que es instalado el pygame todavía. Vamos acá y vamos a guardarlo. Entonces voy a y ahora nos vamos a ir en lo que es Python. El path está correcto. Acá vamos a ponerle en el script, le vamos a poner exit para poder salir, y también vamos a ver si se instaló lo que es el archivo llamado pip y vamos a seleccionar enter. Y como verán, acá me sale lo que son los demás archivos y sí se instaló correctamente. Entonces salgo del cmd y ahora lo que vamos a hacer es instalar lo que es este archivo. Yo lo voy a pasar aquí a mi escritorio, vengo, lo arrastro y lo paso a mi escritorio. Una vez pasado a mi escritorio, voy a seleccionar lo que son todo este nombre, le voy a dar copiar, abro nuevamente el cmd. Y acá lo que voy a hacer es que me voy a ir a lo que abro nuevamente, que son todo este nombre, le voy a dar copiar, abro nuevamente el cmd. Y acá lo que voy a hacer es que me voy a ir a lo que está a mi escritorio, desktop, o donde tengan el archivo. En este caso, si lo tienen en lo que es descargas, se trasladan a ese lugar, o ponen la dirección exacta de ese lugar donde está el archivo. En este caso, por ejemplo, que si yo lo hubiera tenido acá, lo tengo acá, entonces tengo que copiar esta dirección y poder colocarlo acá a la hora de hacer esto. Vamos a escribir pip y le vamos a poner install, y aquí va la dirección de donde se encuentra el archivo. En este caso, como yo ya estoy ubicado donde está el archivo, pues ya solo nada más escribo o pego el nombre del archivo que copié, y aquí ya solo le doy en enter. Espero, aquí ya empieza el proceso a cargar y a poder instalar. Como verán, aquí me dice que la instalación fue correcta, instalación collected package pygame, y aquí dice que se instaló lo que es correctamente el pygame. Entonces acá vamos ahora a importar acá, y voy a ver si se me instaló correctamente. Entonces voy a iniciar lo que es pygame.init, y aquí va ese lugar, todo este nombre le voy a dar copiar. Abro nuevamente el cmd, y acá lo que voy a hacer es que me voy a ir a lo que está a mi escritorio, desktop, o donde tengan el archivo. En este caso, si lo tienen en lo que es descargas, se trasladan a ese lugar, o ponen la dirección exacta de ese lugar donde está el archivo. En este caso, por ejemplo, que si yo lo hubiera tenido acá, lo tengo acá, entonces tengo que copiar esta dirección y poder colocarlo acá a la hora de hacer esto. Vamos a escribir pip y le vamos a poner install, y aquí va la dirección de donde se encuentra el archivo. En este caso, como yo ya estoy ubicado donde está el archivo, pues ya solo nada más escribo o pego el nombre del archivo que
la página oficial, la descargamos, a buscar la extensión de Python, vamos a hacer programar lo que están agregados recién que ingresemos a la carpeta de scripts, vamos a copiar lo que es la ruta de acá arriba y vamos a decirle a nuestro equipo pip install pygame, y listo. Así ya tenemos instalado lo que es pygame en nuestro equipo. Podemos ver que tenemos instalado pygame 2.0 vueltos, o sea, Y ahora voy a arrastrar esta carpeta y la voy a soltar dentro del Visual Studio Code. Ninguna finalidad. Y ahora voy a arrastrar esta carpeta y la voy a soltar dentro del Visual Studio Code. Voy a crear aquí un archivo que se va a llamar holamundo.py. Y simplemente vamos a imprimir hola mundo con print y entre comillas hola mundo. Para ejecutar este programa es bastante fácil, solamente le damos clic derecho y en Run Python File in Terminal. Entonces listo, ahora una vez que esto se ha ejecutado podemos ver que aquí se ha impreso correctamente el hola mundo. Y bueno, ya hemos instalado lo que es el Python, el pygame y hemos configurado Visual Studio Code para programar en Python. Así que eso ha sido todo el contenido por este video. Espero que lo hayan podido entender todo. Nos vemos en un próximo proyecto.
Hey guys, in this video install and once before, so we are going to just click on this link which says Windows x86 64 executable installer, and it's around 25 megabyte file, so it will take few seconds to download. And once this executable file is downloaded, I'm going to just click on this executable file and minimize the browser. And now you can see this first window here. I'm going to just say run, and now you can see this installation wizard is open. So by default, Python is installed on this path on your Windows operating system. But what I would like to do, drive whether it
pygame on Python S, Control Alt and S. Then you want to go here where it says Project Interpreter, and then you want to hit plus, and then you just search up pygame. Then you want to go here where it says Project Interpreter, and then you want to hit plus, and then you just search up pygame or whatever other module you want, and that's all you need to do, and you just hit install. I've already installed it, so I can just type import pygame, run the program, and there. You see that? You're ready to go. Code away, coders.
The actual game is going to be displayed. So for that, I need to define
Run the program, and there.
a couple of variables. The first one is going to be called screen width, and I will set that to 800 pixels. And the second one is going to be screen height, and I'll set that to 600 pixels. Now you notice that I typed these out in caps. The reason for that is these are constant variables. So throughout the game, these variables are never going to change. So the convention is that we use capital letters to define them. Now I use these variables to create my game window. So I'm going to call my game window screen, and I will say that screen is equal to pygame.display.set_mode, and then double brackets, and within here I just pass in those two variables. So the screen width and the screen height. So now let's run this and just see what happens. Now in Sublime Text, to run my file, I can just press Ctrl and B, and I will build the file for me. So you can see down here it says it's successfully ran, it finished, and there were no errors. But nothing really came up. You might notice that a game window flashes up for a second, but then it just disappears again. Now the reason for that is that Python is essentially going through each line on this code and executing them one by one. So it gets to the end, it creates the screen, and then that's it. There's nothing to continue on afterwards, so the program ends. But I need the program to be continuous. I need it to continue running so that I can play and provide inputs into the game, move things around, and so on. So the way now let's just jump straight into the code. So first of all, we're going to be working in this main.py file, height, and I'll set that to 600 pixels. Now you notice that I typed these out in caps. The reason for that is these are constant variables. So throughout the game, these variables are never going to change. So the convention is that we use capital letters to define them. Now I use these variables to create my game window. So I'm going to call my game window screen. And I will say that screen is equal to pygame.display.set_mode, and then double brackets, and within here I just pass in those two variables. So the screen width and the screen height. So now let's run this and just see what happens. Now in Sublime Text, to run my file, I can just press Ctrl and B, and I will build the file for me. So you can see down here it says it's successfully ran, it finished, and there were no errors. But nothing really came up. You might notice that a game window flashes up for a second, but then it just disappears again. Now the reason for that is that Python is essentially going through each line on this code and executing them one by one. So it gets to the end, it creates the screen, and then that's it. There's nothing to continue on afterwards, so the program ends. But I need the program to be continuous. I need it to continue running so that I can play and provide inputs into the game, move things around, and so on. So the way to achieve that is to use a game loop. Now if you've already worked in Python, or if you've done some tutorials previously, you'll be familiar with different types of loops. The one I'm going to be using here is a while loop. So this while loop essentially is going to take some kind of condition, and as long as that condition is met, the while loop is going to continue executing. So for this, I'm going to create a new variable. So I'll add a little comment here first of all to say main game loop, and I will create a variable called run, and I will set this variable to true. So then here I can say while run, which essentially is shorthand for while run is equal to true. So if I say while run, then we'll execute all the code that's within here. So for the moment, there's nothing here, but if I was to run this code as is, the game would hang, because it would go into this while loop and it would say, okay, well, the run variable is set to true, therefore we just continue executing this code that's within here. And it will just continue doing that forever because there is no exit out of this while loop. There's no way for me to end the game within this code. So before I go ahead and try and run this, I need to make sure that I add a way of getting out of the loop within here first of all. Now the normal way for exiting out of a game would be to just click the X in the top right corner. And that's something that we can detect within Pygame. So every interaction, such as moving the mouse, clicking the mouse, or pressing any key on the keyboard, is going to be detected within Pygame as an event. So what I can add within my while loop, note this is indented to show that it's within the while loop, is an event handler. So I'll add a comment to say event handler. And the way we iterate through all the events is by using a for loop. So I can say for event in pygame.event.get. And this essentially allows me to look for any of the events that have been picked up. Now the event that I want to look for is if event.type is equal to pygame.quit. Now this event is equivalent to clicking the X in the top right corner. So when that's happened, this condition will be met. So when that's met, I want to exit this while loop. And as I already mentioned, this while loop is based on this run variable here being true. So that means that to exit this while loop, all I need to do is set this variable to false. So we can just say in here run is equal to false. And now as soon as I click that, this variable is going to change to false. This condition will no longer be met and the while loop ends. So just to clean everything up at the end, once we've exited this while loop, we want to shut the game down. So we just say pygame.quit. So similar to initially saying pygame.init to initialize it, we now say pygame.quit to close it down. And notice that this isn't indented within the while loop. So this comes after the while loop has been exited. Now let's execute the game again and just see what happens. So you can see the game window has come up and now it's actually stayed. I can move it around. There's nothing to interact with yet. It's just a black screen, but I can click up here and close it down. So it's just a black screen, but I can click up here and close it down. So my basic game loop is working well. Now if I run it again, you'll notice up here it just says pygame window. I don't really want that to say that. I want it to actually be the name of my game. So we can update that caption. Now just here where I've created my initial game window with this screen equals command, just underneath that I can type pygame.display.set_caption, and here I can just put whatever I want the game window to say. Now in my case I'm just going to call this dungeon crawler. And if I run this again, you can see at the top now it's changed to dungeon crawler. Now before I move on to the next section, there is one thing that I want to do just to tidy things up a little bit. When I define these two variables up here, I explained that they're both constants. Now you'll notice I actually have a file here called constants.py. At the moment it's just empty. There are going to be variables such as these two that are going to be used throughout the different modules and the different files. So to make them easier to share, it would be better if I was to define them all within this file and then call them in whenever I need them. So what I'm actually going to do here is go back into my main.py and cut them out from here. So I don't want to define them within this code here. I want to take them over to constants and paste them in here. So now these variables are accessible for any of the other modules that import this file. And then now before I move on to the next section, there is one thing that I want to do just to tidy things up a little bit. When I define these two variables up here, I explained that they're both constants. Now you'll notice I actually have a file here called constants.py. At the moment it's just empty. There are going to be variables such as these two that are going to be used throughout the different modules and the different files. So to make them easier to share, it would be better if I was to define them all within this file and then call them in whenever I need them. So what I'm actually going to do here is go back into my main.py and cut them out from here. So I don't want to define them within this code here. I want to take them over to constants and paste them in here. So now these variables are accessible for any of the other modules that import this. So we save that, we go back to the main.py file, but now of course if I run this, I get an error because it doesn't know what these variables are. I know that they're within this constants.py file that's just next to in the same folder, but the game doesn't know that. So I haven't told the program to look for these variables. To do that, I need to import the constants.py file into my main.py file. So right at the top where I've got my imports, I just say import constants. And now everything from here is going to be imported into main.py. So here I can call those variables through, but to make sure that they get called correctly, I need to add this as a prefix. So we'll say constants.screenWidth and constants.screenHeight. So if I run this again, I've made a typo somewhere. Oh yeah, I've missed out the S here. Run this again, and there we go. So now the game window is coming up just as it was before, and I'm able to close it down, so it's all working correctly, but it's now pulling the variables from a different file, which as the game project goes on, it's going to get longer and longer and contain all of our constant variables. Now that the game window is set up, the next thing we want to do is create the character. Now I already have a file here called character.py. At the moment it's blank, but this is where we're going to create it. And we'll use classes for this. There's going to be elements of object-oriented programming here. So we'll say class character, and notice that the C is capitalized. Then the first thing we want to have here is our constructor, which is our init method. So you'll say def init, and then the first argument is always self, and then any arguments that we're going to need are going to follow in here. Now for now, we're just going to keep it simple and we'll start with the coordinates. So I'll put X and Y as arguments, and that's going to allow me to position the character on the screen. Now before I get into loading images and sprites and so on, we're just going to start very basic and use a rectangle to represent the character. So we'll say self.rect is equal to pygame.rect, and here we just follow the pygame convention for creating a rectangle. So I need to give it an X coordinate, a Y coordinate, and then the width and a height. So we'll say 40 by 40. Now notice I haven't used this X and Y variables within here just yet, but we'll use that in the next line. So this just allows me to create the rectangle. Now I can position that rectangle. So I can say self.rect.center is and we'll use classes for this. There's going to be elements of object-oriented programming here. So we'll say class character, and notice that the C is capitalized. Then the first thing we want to have here is our constructor, which is our init method. So you'll say def init, and then the first argument is always self, and then any arguments that we're going to need are going to follow in here. Now for now, we're just going to keep it simple and we'll start with the coordinates. So I'll put X and Y as arguments, and that's going to allow me to position the character on the screen. Now before I get into loading images and sprites and so on, we're just going to start very basic and use a rectangle to represent the character. So we'll say self.rect is equal to pygame.rect, and here we just follow the pygame convention for creating a rectangle. So I need to give it an X coordinate, a Y coordinate, and then the width and a height. So we'll say 40 by 40. Now notice I haven't used this X and Y variables within here just yet, but we'll use that in the next line. So this just allows me to create the rectangle. Now I can position that rectangle. So I can say self.rect.center is going to be at coordinates X and Y. So now these coordinates are going to be used to position this rectangle. But now we need to make sure that we link this information in here, this code within this character file, into our main file. Now remember, I've previously done this with the constants, so I just repeat the process for the character. But within here, I actually have a class that I want to import. So rather than saying import character, I'm going to say from character, which is the name of the Python file. It's got a small c in the beginning. Import character with a capital C. So it's saying from this Python file, import this character class. And now that this is done, we can use this to create our player. So we'll go down here just above the main game loop. We'll add a little section to say create player. And we'll say player is equal to character, which is the name of that class. And then within here, we need to make sure that we pass in the arguments that it needs. So it's asking for, well, you can ignore self, but then it's asking for an X and a Y coordinate. So let's just say 100 and 100. Now let's run this and see what happens. You notice straight away I get an error. Now this error is going to link me back into this character class, which I know that I've just imported from this file. So if I go in here, it gives me an error that says pygame is not defined. Now this function here, when I create my rectangle, begins with pygame.rect. I have imported pygame within my main file. However, I've not imported it within this module here. So this is an important distinction to keep in mind. So although this code is being called into my main file, which does have pygame imported, on its own is trying to call functions here that haven't been imported. So I actually need to import pygame again up here within the character class. So let's try this again. And now there's no errors. So the code is running successfully. The game window is coming up, and I know that I've created this player because there was no error, but we're not seeing anything on the screen yet. So to be able to actually display things on the screen, we need to explicitly tell pygame to draw things for us. So we go back into this character class, and as well as the constructor, we're going to add another method. So essentially just another function within it. Now make sure that the indentation is correct. So it needs to be indented within the class method, within the class, but not within this method here. So we'll say def draw, and always these methods must begin with self. And then within this method, we want to draw the rectangle onto the screen. So we already have the rectangle created. That's up here, self.rect. So we can say in here, pygame.draw.rect. And then the function here is going to take a few different arguments. So the first argument is actually going to be the surface that I want to draw this onto. So basically the game window. Now I've created my game window here, so it's called screen. Now what happens if I just put screen in here? Let's see. So put screen, then the next argument is the color that I want to use for the rectangle. So let's just say 25500, so it's going to be red. And then lastly the rectangle itself, which is self.rect. Now if I run this code, initially nothing happens. The reason for that is because this draw method is not being called anywhere. So although it exists, and I actually know that there is an error within it, nothing happens. So we need to make sure that this draw method is called somewhere within the main loop or the main file to actually display it on the screen. So within this while loop down here, but above the event handler, we're just going to make a bit of space and say draw player on screen. And now to call that method, I need to refer to the player object that I've created. So I say player.draw. Now if I run this again, I'll get an error straight away. And it says that screen is not defined. Well, I know that I have defined screen up here, but within here, I don't have anything like that called up on screen. And now to call that method, I need to refer to the player object that I've created. So I say player.draw. Now if I run this again, I'll get an error straight away. And it says that screen is not defined. Well, I know that I have defined screen up here, but within here, I don't have anything like that called up. So this demonstrates why it's important to be able to pass information back and forward between all of my different files. So what I actually need to do is add another argument here. Now I'm not going to call this screen, I'm going to call this surface because that's what they are within Pygame, they're surfaces. So and I will change this to surface. And now when I go and call my draw method from my main game loop, I need to pass that in as an argument. Well, in this case, all my surfaces. So and I will change this to surface. And now when I go and call my draw method from my main game loop, I need to pass that in as an argument. Well, in this case, my surface is called screen. That's the game window. So I'll pass the game window in here. If I run this again, it's now executing correctly, but I'm still not seeing anything on the screen. Now, as this game grows, there's going to be a whole bunch of different draw methods. I'm going to be asking Pygame to draw many different sprites on the screen. So as this happens, at the very end of this while loop, I need to tell it to take my display window and update it with all of these changes. So just underneath this event handler, right at the bottom of my game loop, but make sure that you're still indented correctly within this while loop, we say pygame.display.update. And this essentially tells it to take all of these draw methods that I'm going to be calling throughout the loop and update the display with everything. So if I run this again, you can now see a little red rectangle has appeared on the screen. So this is this player class that we've created and it's at the coordinates that we specified, which are 100 by 100 pixels, and it's in red, just as we called it up. And now we can tidy this up a little bit more. So this color here is effectively another constant. So what I can do is cut this from there. I can go into my constants file and I'll have another little section down here where I define colors. So I can say that red is equal to this RGB value of 25500. Now I can go back into my character file and value of 25500. Now I can go back into my character file, and at the top, just like I did previously, I import my constants. So now down here where I've got this little space in between the commas, I can say constants dot red. And if we run this again, we should see the same red rectangle appearing in the same position. Now that we've got the player created, the next thing we want to do is add in some movement. Now, we're going to be using the keyboard to move the player around, which means that we need the game to be able to take these inputs. You remember previously that I said that for any kind of inputs into the game, we use this event handler. So I can just expand this section to look for additional events, which are going to be keyboard presses. Now underneath this section here, where I'm currently looking for the quit event, I will add another little section, make sure the indentation is correct and that we are just indented within this for loop. And we'll add a comment to say take keyboard presses. So here it's going to be a slightly different event type. So now we say, just as above, we say event type is equal to, but now instead of it being pygame.quit, it's pygame.key down, all caps. And within here, I can now look for a specific key being pressed. So we can just say if event.key is equal to pygame.K_A. So if the A button has been pressed, well then I want to be able to move left. So for now, let's just output these things onto the screen to make sure it's all working. So we'll just print left, and then we copy this down for the other keys. So we copy that one down, and we say if event key is, so we want to move right, so that's D. If D is pressed, then it's saying right. Okay, and then we just paste this a couple more times for up and down. So if event key is W, then we're printing up, and if event key is S, then we're printing down. So let's just test this out first of all. Run that, and now I'll press W, it says up, S, down, A, left, and D, right. Okay, so that's working correctly. It's taking the correct inputs and giving us the correct outputs. But of course, we're not just trying to display this information down here. We actually want to be able to move the player around. So rather than these print statements, I'm actually going to have some variables that are going to be controlled based on these inputs. So we go right up to the top before the game loop and before we create the player. So just underneath this section where we create game window, we'll add another comment to say define player movement variables. And here I'm just going to define 4 variables for movement directions. Say moving underscore left is equal to false. Moving, in fact, I'll just copy it down. So I'm just going to be doing this for each direction. So moving left, moving right, moving up, and moving down. So this essentially just says that when we start the game at first, then the player isn't moving at all, which is correct. So all of these variables are set to true. Now these variables themselves, they're just triggers. So they're not going to move the player around, they're just going to trigger the movement itself. So what I now need to do is go into my game loop, and before I draw the player on the screen, I want to first of all do any positional updates. So I want to make sure that I move the player around before I draw him. So let's just add a comment here to say calculate player movement. And I will define an additional couple of variables here. So I'll say dx is equal to 0 and dy is equal to 0 as well. So these d's, they stand for delta. So delta x and delta y, which just basically means the change in the x and the change in the y. So to begin with, they're both set to 0. And I've created this very high quality image here to explain what these variables mean. So the red rectangle, well, that's our player. dx and dy, they're essentially corresponding to each of the coordinates. So the dx variable is saying how much are we moving left or right, and the dy variable is saying how much are we moving up and down. So now we can use these triggers up here to actually change these variables, and that's what's going to move the player around. And this is going to be done with a bunch of if statements. So first of all, we'll just say if moving right is equal to true, well then we want to change the x coordinate of the player. So we need to increase the x coordinate, meaning that this dx variable, which is the change in the player's x coordinate, it becomes a positive value. Now here I would just use a speed variable. So how fast do I want the player to move? Well, let's say 5 pixels. Okay, so that's moving right. Now let's do the same for moving left. But now because we're moving left, the x coordinate is being decreased. So the dx variable is a negative value. Now we'll do up. So if we're moving up, and now it's actually the y coordinate that's being affected. So the y coordinate is changing to move the player up the screen. However, keep in mind that in pygame, the top left corner of the screen is coordinate 0, 0. So to move down the screen, the y coordinate actually increases. Means that if you're moving up the screen, the y coordinate decreases. So that needs to be a negative value. And then we just paste this one more time and we say if moving down is true, then the dy variable, well, like I said, the y variable would increase as you move down the screen. So this is a positive. So now we need to link our keyboard inputs to these new variables, these moving left, right, up and down triggers. Well, we can just replace these print statements with them. So now right, up and down triggers. Keyboard inputs to these new variables, these moving left, right, up and down triggers. Well, we can just replace these print statements with them. So now when we say left, rather than printing it out, we just say moving underscore left is equal to true. And we can just copy this down and do the same thing for the others. So this one is moving right is equal to true, moving up, and lastly moving down. So now we've got a connection between all these things. So the event listener and all these keys are going to be triggering these variables. And then those variables are going to be controlling the speed. So this dx and dy variables. Now, before we go too much further, let's just see whether this is actually working at all. So let's print out the dx and dy variables. We'll use a temporary print statement here, just as a way of debugging the code. So if anything is going wrong, we can catch it early. So these variables, they're integers, and we need to make sure we convert them into strings by saying str and then putting the variable in brackets. So the dx variable plus, let's leave a comma and a space, the string version of the dy variable. Now let's print this out. So at the moment it's 0, 0 because that's what they begin as. So if I press, now let's print this out. So at the moment it's 0, 0 because that's what they begin as. So if I press the keys, you can see now it's changing to 5 for dx, -5, and then I can do the same thing with up and down. We need to make sure we convert them into strings by saying str and then putting the variable in brackets. So the dx variable plus, let's leave a comma and a space, the string version of the dy variable. Now let's print this out. So at the moment it's 0, 0 because that's what they begin as. So if I press the keys, you can see now it's changing to 5 for dx, -5, and then I can do the same thing with up and down. So I'm able to change these variables around. There is a little bit of an issue here, which some of you may already have picked up. We'll demonstrate what happens and then we'll come back and fix the problem. But for now, we don't need this print statement anymore. So that was just a temporary thing to be able to see what's going on in the background. So we can delete that and we can actually start adding a movement method to the character. So all of these kind of things, anything that's going to be controlling the player or essentially attached to the player is going to be done within this character class. So currently we have our constructor at the top and we have a draw method at the bottom here. So in between the two, I'm going to add another method. So we'll say def move. So remember, this always has to take the argument of self first of all. And then we need to pass a couple more arguments here. Well, because this is going to be a move method, it means we need to move the player around the screen. So it goes to say that what we need to know is how much we're going to be moving by. So that's where we're going to call in our dx and dy variables. Now to move the player, we can simply update the rectangle's positions. So we can just say self.rect.x is increased by the dx variable and self.rect.y is increased by the dy variable. And that's it. That's going to take care of the movement because in the next section where we have the draw method, we draw that rectangle onto the screen at its own coordinates. So by updating the coordinates first, it automatically takes care of the next section, which is going to be drawing it in those new coordinates. And now to actually call that method, we can go back into the while loop. So if you notice, if we run this code now and try and move the player around, nothing happens. And the reason for that, of course, is that this method needs to be called. On its own, it won't execute. So here, after we've defined what the dx and dy variables are going to be, we add another little section to say move player. And then we can call the player's move method. So we say player move, and then we have to pass in those two arguments, remember? So dx and dy. So now let's run this and just see what happens. So we've got a rectangle here. I'm going to press D and whoa, okay. So we created a massive red line here instead of really moving the rectangle. There's a few things to unpack here and I kind of expected this to happen. So let's fix these things one by one. Now the first issue that we want to address is why rather than moving across the screen, it just creates this long red line across it. Now the reason that's happening is because each iteration of the game loop is showing what has gone on before. So basically, we're never actually clearing the screen. We're not getting rid of what was there previously. So as the rectangle moves across, all the previous positions of the rectangle that we drew on the screen before it, they stay. So as it's moving, it's leaving a trail of all the previous places that it was. Now what we need to do is make sure that we clear the screen every time we go through this while loop. And the easiest way to do that is just to fill the entire background with a specific color. So right at the top of the while loop, before we even get into the player movement, we're going to call a function. We'll say screen.fill, and then we'll call a color. So whatever color we want to fill the background with. Now, if you remember, I put all of these kind of things within this constants file. So I'm going to add another color within here. Now this color is going to be BG for background, and I'm going to set 40, 25, and 25. So now I can call that color in here by just saying constants.bg. Because remember, I've already called constants, or I've already imported constants within this file. So this is going to call that color. Now if we run this again and I press D, you notice the background color has already changed. So if I press D now, well, now I'm not leaving this trail, but the rectangle just shoots off the screen completely. So we fixed one problem. So the next problem that we want to fix is why it's moving off so quickly, like why it's basically just shooting off the screen in an instant. The reason for that is that within this while loop, every time this iterates, every time we go through the while loop, we move the player by the dx variable. Now because the game right now is very simple and very basic, it's able to run at a very high frame rate. So within one split second, it can run this heaps of times, and as a result, it moves the player loads and loads of times at this speed. What we need to do instead is cap the frame rate. We don't want the game running too fast. We want it to be running pretty much the same speed on all different computers. So for that, we need to define a clock. So we go right up at the top where we've got our game window being created. And just underneath that, I will add another comment to say, create clock for maintaining, that's not how you spell it, maintaining frame rate. And we'll say clock is equal to pygame.time.clock. Notice that it's got a capital C. Now we can go into the game loop here, right at the top, and the very first thing we do, even before we fill the screen with this background color, is that we make sure we fix the frame rate. So we'll say control frame rate. So we'll say clock, which we just created, dot tick, and then here is where we put in the frame rate that we wanted to run at. So typically you would use 60 frames per second, so I would just put the number 16 here, but because this is another constant, what I'm going to do instead is go into my constants file, and right at the top, before even setting the screen width and height, I will say FPS, my frames per second is 60. Now we can go back here and replace this number with constants.fps. Okay, so let's try this again, run the game, and now you can see the movement is a lot more smooth. But the rectangle still just slides off the screen. So if I run this again, I'm not going to hold the button down. I'm just going to press D once. It doesn't stop. It just keeps moving across the screen. So that's the third problem that we need to fix. And this all has to do with this event handler section here. Basically, I've only done half of it. So what I'm looking for at the moment is if the key has been pressed down. So if I press, for example, D to move to the right, this variable or this trigger is set to true. The problem though is that this trigger is then never set back to false. The only time it's ever false is when we first start the game. So right at the top here where we define the variables, they're all set to false. But after that, as soon as I press one of these keys, the variable is set to true and then it just gets stuck. So as far as this section up here goes, well, once it's met, it never goes back. Basically the player never stops even when I let go of the key. So the solution, well, you may have guessed it, I basically need to look for, as well as when I press the key, I need to now check if I've released the key. The code is going to be very similar, so I'm actually just going to copy all of this down, but just update it a little bit. So underneath here, I just need to make sure the indentation is correct so that this if statement lines up with this if statement and they're just indented one level inside the for loop. So now instead of taking keyboard presses, let's change this comment to say keyboard button released. And now the event type is, instead of being key down, it's actually key, well, you may have guessed it, it's key up. All of this is exactly the same. So we're still looking for the same keys and we're still having the same variables as triggers, but now instead of them being set to true, they're being set to false. So if that key, for example, the A key has been released, moving left becomes false. So in theory, once we update all of this, the rectangle's movement should become more reactive. So if I press D, it moves. If I let go of D, it stops. And S, A, and W. So there we have it. I now have this full movement of the rectangle around the screen. I'm able to control it and I'm able to let go and the rectangle stops. So that's almost everything with the movement, but there is one thing that is not easily noticeable. So just pay attention to key up. All of this is exactly the same. So we're still looking for the same keys and we're still having the same variables as triggers, but now instead of them being set to true, they're being set to false. But now instead of So if that key, for example, the A key, has been released, moving left becomes false. So in theory, once we update all of this, the rectangle's movement should become more reactive. So if I press D, it moves. If I let go of D, it stops. And S, A, and W. So there we have it. I now have this full movement of the rectangle around the screen. I'm able to control it, and I'm able to let go, and the rectangle stops. So that's almost everything with the movement, but there is one thing that is not easily noticeable. So just pay attention to how fast it moves when it goes left and right, how fast it moves when it goes up and down, and how fast it moves when I hold both down for a diagonal. So you'll notice if I move diagonally, I can actually move a lot faster than when I'm just moving up or down. Now the reason this is happening is that my dx and dy variables control how fast the player moves. So normally it's only moving 5 pixels, but if I hold down 2 of the keys, like up and left, well, it's moving 10 pixels. So it's moving left 5 and it's moving up 5 at the same time. So that means that when the player moves diagonally, I actually need to control that movement separately. So if I use another one of my high quality sketches, it can kind of demonstrate what's going on. The dx variable is moving us left and right, dy is moving us up and down. So this diagonal here is what we need to work out. Essentially, this diagonal is not the sum of dx and dy. If you can think back to your Pythagoras theorem, you'll be able to figure out how to calculate this diagonal line here. But I'm not going to get into all of that just now. I'm just going to show you how to essentially do this. So we go back into the character class where we have this move method, and before we just take those variables and update the player's rectangle's coordinates, we're going to do a little check first of all. So I'm going to add a comment here to say control diagonal speed. And the diagonal speed only needs to be controlled if both dx and dy are being pressed or are not 0. So I can just add a little check here. I can say if dx is not 0 and dy is not 0, well, that means that both of them are either positive or negative, so the player is moving diagonally. So I need to modify them slightly. So I need to say that dx is equal to dx multiplied by math dot square root of 2 divided by 2. And I repeat the same thing for dy, but I just change these variables. And that's going to smooth out the diagonal movement. Now notice I have just called in an additional module here, so I need to make sure that I import it, otherwise I'm going to get an error. So let's just say up here, import math. Okay, so let's try this movement. Let's see if I got that working correctly. So left, down, right, right, down, that's okay. Let's try diagonals. Okay, and you can see the diagonal speed. See if I got that working correctly. So left, down, right, right, down, that's okay. Let's try diagonals. Okay, and you can see the diagonal speed is pretty much the same as the left and right movement speed. speed. So we've got that working a lot better now. Now, one little thing to tidy up here, again, you've noticed that I've just put in numbers straight into here. Well, we don't really want to do that. We want to be making sure that we control these variables in one place. So this is my player's speed, and that should be a fixed variable. I want them to always move at the same speed. So I can go into my constant file here, and let's say just underneath screen height, we'll say speed is equal to 5. So now, rather than setting it to manually to a variable of 5, well, you've already guessed it, I'm going to say constants dot speed. And then I can just copy this down for the other ones, but this one is negative, and that one is positive. So let's just run this one more time and make sure that it's still working correctly. And there we go, the movement is all working fine. The next thing that I want to do is load in some player images to replace that red rectangle. So we go back up to the top here, we create the player instance, and I'm going to add a little section here to load the player image. So I will say player image is equal to pygame.image image.load, and then within these brackets I need to give the file name and location. So my files here are stored within the assets folder. So if we go into the assets folder, I have images, then characters, then all the different characters I'm going to be using, but the player is the elf character. So we go into elf, there's two different folders for different animations. And within idle, there's 0, 1, 2, 3 PNG. So these are the different frames of the animation. Now we'll get to all of that later on when we do the animations, but for now I just want to load this first image, the file name and location. So my files here are stored within the assets folder. So if we go into the assets folder, I have images, then characters, then all the different characters I'm going to be using, but the player is the elf character. So we go into elf, there's 2 different folders for different animations, and within idle there's 0, 1, 2, 3 PNG. So these are the different frames of the animation. Now we'll get to all of that later on when we do the animations, but for now I just want to load this first image so I've got something to show instead of the rectangle. So now in here I need to put in the location and the name of this file relative to where my main.py file is. So from here, because it's in the same folder as my overall dungeon tutorial, I can put in assets / images, then character, then elf, and so on. So we'll say assets, images, characters, then elf, then I want idle, and then the file name is 0.png. And at the end of this sentence we need to add .convert_alpha. Now this does a couple of different things. So this first part converts the image to match the format of our game window, and then the second part just makes sure that the image stays transparent. Or rather, the transparent pixels on the image remain transparent. With this image now loaded, we can pass it in as an argument into this class. So after this second 100, let's pass that player image in. Now of course, this also means that we need to go into the character file and make sure that we update this constructor to be able to receive this argument. So we update this to just say image, and now we can take that and assign it to the class. So we can say self.image is equal to image. Now down in the draw method, as well as drawing this rectangle, just before it I'm actually going to draw the image. So I will say surface.blit, and what is it that we want to blit? Well, it's the image, so it's self.image, and the location is going to be at the location of the rectangle, so self.rect. So this rectangle is actually what controls the position and the collisions and the movement. The image is just always drawn at its location. So underneath everything, there's always this rectangle. So let's go back to the main file and run this and just see what happens. Okay, so we still have our little rectangle. So there may well be an image there, but we can't see it because the rectangle is being drawn over it. Now I want to keep this rectangle because it does help me identify the outlines of this image, and that'll be useful when we come to putting in the collision and so on. So what I can do is update this draw.rect section by adding one last argument at the end. So this argument is essentially the width or the line thickness of the rectangle. When I didn't add anything in, it created a solid rectangle. But if I add a number in here now, instead it's going to give me an empty rectangle, and this is how thick the rectangle lines are going to be. So if we go back, run this again, you can now see instead of a solid rectangle, I've got these lines instead, and the line thickness here is 1 pixel. And underneath it all is a tiny little image of a player. Now at this point, some of you may encounter an error that says that file or folder cannot be found. So this sometimes happens when you try to load an image with the file name defined here. If Python then tries to look for this file and it can't find it where it thinks it should be, it's going to throw you that error. So the first check to do if you experience that problem is just make sure that there are no errors when you've typed out the file location, and that the folder structure that you've got here is exactly the same as what I've set up. If that still doesn't fix it, then the problem could be within the editor. So you would need to make sure that you're executing your code from the folder that you're currently in. So that would mean going into File, Open Folder, and then opening this Dungeon folder. This is especially important in VS Code because otherwise it doesn't run it from the correct location and then it can't find the files. And lastly, if you're still getting errors with the file not being found, well then you could replace this by putting in the entire full file path. So that would mean going into your File Explorer and then figuring out where this file is located on your computer. And you would begin this by saying, for example, C, and giving it the entire file path that way. So hopefully at this point everyone is in a position where we've got the game running and we've got this outline of a rectangle and a tiny little image in the middle of it. So the problem of course course, is that the image is far too small. So we need to scale that player up a little bit. Now the chances are that I'm going to have to scale a whole bunch of other things to match. So rather than scaling this individually, I'm going to add another variable to my constants file. So just at the top up here underneath my screen height, I will add another variable called scale, and I will set this to 3. So this is just going to be the global scale that I'm going to be using for the large majority of the images that I'm going to load in. Now to scale the image, we go back into the main file, and just after we loaded it, we can then apply another function to it to be able to change its size. So we say player underscore image, so it's still the same file, is pygame.transform.scale, and the image we want to scale is the original player image. And then we need to provide the width and the height that we want to scale to. So you don't just scale by a size, you need to actually give it the new size in pixels. So we set another set of brackets in here, and well, first of all, it's the width. So we need to figure out what the current image width is. So say player underscore image dot get underscore width, multiply that by the scale. So that would be constants.scale, because remember it's within the constants file. So that's our width, and we do the exact same thing for the height. We say player underscore image dot get underscore height multiplied by constants.scale. Okay, and then just make sure that I've got enough brackets. I think I need one more. Let's try this. Okay, so the code runs fine, and you can see the image has gotten bigger and it's a bit more relative to the size of the screen. So that works, but you can see this code is quite messy. That whole line is longer than, well, my entire window here. I think I need one. One more. Let's try this. Okay, so the code runs fine, and you can see the image has gotten bigger and it's a bit more relative to the size of the screen. So that works, but you can see this code is quite messy. That whole line is longer than, well, my entire window here. So what we're going to do is create a helper function. So it's just a little function that we create to, well, essentially help ourselves out a little bit. It will speed things up, especially for things that we have to do over and over, such as scaling various images. So up here, before I load this image, I'm going to create a new function. So I'll add a comment to say helper function to scale image. And I'll say def scale underscore img. And this function is going to take a couple of arguments. The first one is going to be the image itself. So you need to give it an image to scale first of all, and then you need to give it a value for the scale. So you need to tell it how big you want that file to be. And this way we can now take all of this stuff and put it in here instead. Well, the first thing we need to work out is the width and the height of this image that's being passed in. So we'll say w is equal to image.get underscore width, and then h is equal to image.get underscore height. And then lastly, we scale the image. So we can say new underscore image is equal to pygame.transform.scale. So exactly the same function that I used down here previously. And what is it I'm scaling? It's the image. And what I'm scaling it by, well, now I've got this W and H value instead. So I can just say W multiplied by scale and H multiplied by scale. And then we need to return this back from the function. So when something is passed into the function, we want to take the scaled image back from it. So we need to add another line here to say return new image. But we can actually just simplify this and just return this section up here. So we'll get rid of this new image part and we'll just say return that. So now it's going to take an image, work out how wide and tall it is, and then it will return the scaled version of that image. Okay, so now let's try and apply this new helper function where we create our player image. So we'll just tidy this up, and instead of calling that function, we call this new helper by saying scale_img. We pass in the player image, and then we can delete all of this stuff here because all we need to pass is constants.scale. Okay, so let's run this again, and there we go. So it's scaling new image. But we can actually just simplify this and just return this section up here. So we'll get rid of this new image part and we'll just say return that. So now it's going to take an image, work out how wide and tall it is, and then it will return the scaled version of that image. Okay, so now let's try and apply this new helper function where we create our player image. So we'll just tidy this up, and instead of calling that function, we call this new helper by saying scale_img. We pass in the player image, and then we can delete all of this stuff here. Here, because all we need to pass is constants.scale. Okay, so let's run this again, and there we go. So it's scaling up just as it was before, but now the code is much neater here, and we've just got this one function that we can reuse again and again. So now that this image is loading in correctly, we can start working on making it a little bit more responsive. So for a start, when the player moves left or right, he's always facing the same way. So when he's moving right, it's okay, but when he's moving left, he kind of just moonwalks backwards. So let's add in a way of making him flip around in the direction he's facing. So to do that, we go into the character class and add an additional variable here to act as a trigger. And we'll say self.flip, and we set it to false to begin with. Now we can use this variable to flip the image around. So we go down into the draw method and we add another little section here. Just before we blit the image onto the screen, we're going to flip it first of all. So we'll say flipped_image is equal to pygame.transform.flip, and then the image we want to flip is self.image, and then it takes two additional arguments, and these arguments determine whether it's being flipped left or right and up and down, so the y-axis and the x-axis. So let's just play around with it. So first of all, let's just put false in both of them, and now rather than directly blitting self.image, I actually want to blit this flipped image. So let's get rid of that and put flipped_image. and run this code again. Okay, so nothing is flipped. Flip, and then the image we want to flip is self.image, and then it takes 2 additional arguments, and these arguments determine whether it's being flipped left or right and up and down. So the y-axis and the x-axis. So let's just play around with it. So first of all, let's just put false in both of them. And now, rather than directly blitting self.image, I actually want to blit this flipped image. So let's get rid of that and put flipped underscore image and run this code. So let's get rid of that and put flipped underscore image and run this code again. Okay, so nothing is flipped, right? It's exactly the same as it was previously because both of those variables are still false. So let's make this first one true. And we run it again. Oh, and now he's facing the other way. So now he's looking to the left instead of looking to the right. So you can see what that flipped variable here does. If we set this back to false, and just to demonstrate, although we're not going to be using this, let's just set the second one to true as well. And now you can see he's standing upside down. So that's how this flipped variables work. And it's quite an easy way of being able to control the player direction. So we'll change this back to false. So now he's not flipped, he's looking to the right. And we can actually just use this self.flip variable in here. Instead of having this always set to false, we can set this to self.flip. So now whenever we trigger this variable between true and false, that's when we're going to trigger the player's rotation between looking left and looking right. So how do we actually determine whether he's going to be looking left or right? Well, that depends on his speed, essentially. Remember this delta x variable. This variable was either positive if he's moving right or negative if he's moving left. So we can just check which way that variable is pointing us. So just before we have this section for controlling the diagonal speed, we're going to add another little check. So we'll say if dx is less than 0, well, this means that he's moving left. So the x coordinate is decreasing, he's moving left. That means we want to flip the player. So self.flip becomes true. Otherwise, if dx is greater than 0, we want to flip him back. So we'll say self.flip is equal to false. So now if we go back, run this code again. So I move to the right, he's facing that way. I move to the left, and he flips around. So now, whichever way I'm moving, he always faces that direction. And you notice that even when I let go of the button, he doesn't flip back, he stays looking in that direction. Now the next thing we want to work on is adding in some animations. So if we go back to this folder structure here, I've got this idle folder that has 0, 1, 2, and 3 within it. And these are just different frames of the idle animation. So first we need to load all of those images in and store them within the game. Now currently I'm doing this by loading in the individual image, but I need to kind of automate this because I'm going to have 4 images loaded in one by one. I can just use a for loop to load them in. So first of all, let's create an empty list that's going to store all these images for us. We'll say animation underscore list is equal to an empty list. And then we add a for loop. So we'll say for I in range. And well, there's 4 images, so the range is going to be 4. Now we can indent both of these lines. And I'm going to slightly change them because now it's not just going to be the player image. We're actually going to be reusing this code later on to load in the enemies as well. Not just going to be indent both of these lines. And I'm going to slightly change them because now it's not just going to be the player image. We're actually going to be reusing this code later on to load in the enemies as well. So let's make it a little bit more generic and replace that player image with just img, short for image. Then we do the same with the one below, and we make sure that we update this variable here to img to avoid any errors. Now the idea here is that we're using this for loop to load in these images one by one. However, the file name that we're looking for is still 0.png, so we're actually just going to load that same image in 4 times. Well, what we need to do is use this I variable here that's going to be increasing as this for loop goes on and put it in here instead. So that way at the first iteration, the I variable is going to be 0, it's going to load in 0.png, then the I variable goes to 1, we load in 1.png, and so on until we've loaded in all 4 of these images. Well, there's a couple of different ways to do that, but essentially we need to take this string and add a variable in the middle of it to replace this 0. So the way that I prefer to do it is to use Python's f-string formatting. So there's a couple of things we're going to do here. First of all, right at the beginning, before we have these quotation marks, we put in an f. And then this allows us to add in curly brackets anywhere within the string and put a variable inside it. So let's put curly brackets here where the 0 used to be, just before this full stop, and add in the variable I, which is this one here. This is our iterator that goes through this for loop. So now with each iteration of this loop, we're going to be loading in the next image. Well, once we've loaded one of these images and then we've scaled it up, we need to make sure that we put it into this list, otherwise the image just gets overridden at the next iteration. So we say animation underscore list dot append img. So now these images are going to be stored into this list, then we move on to the next iteration, load in the next image and store it again in the list and so on. So now when we create this player instance here, rather than passing in this player image, which doesn't actually exist anymore, we want to pass in this entire animation list. Now we go into the character, and within here, when we receive the image, well, we're no longer receiving just a single image, we're actually receiving an animation list. So before we go too much further, let's just make sure that this is all working first of all. So here where we say self.image is equal to image, well, that's no longer being passed in. So what I want to do is take the animation underscore list, and we'll just take the very first entry within that list. So index 0, which should give us 0.png. So if this works correctly, the image is going to be exactly the same as it was before, but we would know that we're passing it in correctly with the entire list. So let's just run this, and okay, there's no errors, and the image is exactly as it was. I'm still able to flip it left and right as I move around. Now it's possible that at this point you may have received an error which said the file could not be found at this line here. This f string formatting is something that was introduced in one of the later versions of Python. So if you are getting an error here and you weren't getting any errors previously, then it may just be that you have an older version of Python. So if you were to update or install the later versions, you should avoid this error. So now that we're passing in this entire list of images into our character class, how do we stop just using the first one? How do we actually animate it? Well, the way this animation is going to work is that we're going to be running through these images within this list very quickly one by one. And essentially by doing that, we give the impression of an animation going on. In reality, we're just showing a number of different still images, but by doing them quickly and showing them one by one after the other, it gives the impression of an animation. So here we need to add a couple of extra variables. So let's go up here and add a variable called self.frame underscore index, and we'll set that to 0 to begin with. So the frame index is essentially controlling which frame of the animation we want to show. Now we begin at frame index 0, of course, because that is going to be the first frame. The other thing we want to know is the update time. So we say self.update underscore time is equal to pygame.time.get underscore ticks. And we use this to measure how much time has passed since the last time we updated the frame, and this essentially tells us to move on to the next frame in the animation. So now when we load the self image, Previously, I manually entered the number 0 in here, but now we've got this variable defined. So we're going to replace that 0 with self.frameIndex. Now we go underneath this move method, and we're going to create a new method called update. So we say def update, and the only argument it needs to take is self. It doesn't need any more. And within here, we're going to handle the animation. So first of all, we're going to create a variable called animation cooldown, and we'll set this to 70. So I'll explain in a second what this is going to do, but essentially the animation cooldown is going to control the speed of our animation. So then we'll add a little comment to say handle animation, and then another comment to say update image. So the first thing we want to do is make sure that we're using the latest image. So we'll say self.image is equal to self.animation list, which is the list of images, at index self.frameIndex. So this frame index will change throughout the update method, which is why we wanted to make sure that we're using the latest image based on this index. Next, we add a little comment to say check if enough time has passed since the last update. So this is where this update time comes into it. So what we want to do is see what time it is right now. So we say pygame.time.get_ticks, and we subtract the last update time. So self.update time. So if the current time minus the time that we previously updated the animation is greater than our animation cooldown, well, that means that it's time to move on to the next frame. So we'll say self.frame_index is increased by 1. We also want to make sure that we update this variable here, because we've just updated the animation. So self.updateTime is the current time, which is pygame.time.get_ticks. So essentially it just resets the timer again. So now let's go back into the main file and actually call that method. So if we just the current time minus the time that we previously updated the animation is greater than our animation cooldown, well, that means that it's time to move on to the next frame. So we'll say self.frame_index is increased by 1. We also want to make sure that we update this variable here, because we've just updated the animation. So self.updateTime is the current time, which is pygame.time.get_ticks. So essentially it just resets the timer again. So now let's go back into the main file and actually call that method. So if we just the current time, which is pygame.time.get_ticks. So essentially it just resets the timer again. So now let's go back into the main file and actually call that method. So if we just run this as it is, nothing happens. There's still no animation, because although we've created this method, it's not being called. And until it gets called, none of this code gets executed. So we go back into the main game loop here, which is this while run section. And just underneath where we're moving the player, but before we draw him on the screen, we'll just add a little comment to say update player. And then we call player.update. Now, this section that I've just added isn't quite complete yet, and it may most likely will throw us an error, but let's just see if it works first of all. Okay, so straight away it failed, but for a different reason than I was expecting. And the reason for this, if we go back into the character class and go up to the top here, I've passed in this animation list, but I never actually assigned it as a self.variable. So before we even create the frame index, let's just take care of that. So we'll say self.animationList is equal to animationList. And let's run this again. Okay, so you can see it ran for a couple of seconds. It started to animate. I don't know if you can see that. And then it kind of seems to crash at the same point and give us an error. And the error says list index is out of range. So if we go back here, you can see where the error is happening. So when we try to update the image to take the latest image based on this frame index, we get an error that says that the list index is out of range. That kind of means that we're trying to access a point within this animation list that doesn't exist. Well, that makes sense because we only have 4 images within this animation, and what we're doing is we're checking how much time has passed since the last update, and then if it's sufficient, then we move on to the next frame. So eventually we're going to get to 0, 1, 2, 3, and then this is going to go up to 4. It's going to try and access an image that doesn't exist. So what we need to do is add another little check after this to reset the animation back to the start. So it just continues to loop. So let's add a comment to say check if the animation has finished, and we'll just look at the current frame index. So we'll say if self.frameIndex is greater than or equal to the length of self.animationList. So that essentially means that we've come to the end of those animations. We have no more images left. So we want to start the whole process over again. So we just reset frame index back to 0. If we go back here again, run this code, now you can see that he's just standing continuously looping through this idle animation. So we want to start the whole process over again. So we just reset frame index back to 0. If we go back here again, run this code, now you can see that he's just standing continuously looping through this idle animation. So that's working a lot better now. We still don't have a running animation, so whenever he moves, he's always idling, but we're halfway there. Now that we've set up this framework for animations, we should be able to add in the additional run animation into it as well. So if we go back to where the animation list is being loaded in, we can expand this section to make it a bit more automated to load in different types of animations and eventually different types of character animations as well. So the first thing to note is that at the moment, what I have is this for loop that runs through 4 times and it loads in all the images from the idle animation. Well, I need to expand this to be able to also take in the run animation. So this section here is going to be dependent on a variable. So that means that I need to wrap all of this in yet another for loop. So before we create that for loop, we'll add another little list up here called animation_types. And in here, I'm going to put idle and run. So this essentially tells me which types of animations I actually have and want to use, and it corresponds to the names of these folders up here. Now I'll just add a little comment underneath to say load images, and then I still have this animation list created, so that one is still correct, but then underneath it I add another for loop, and this for loop is going to be iterating through for each animation in animation types. So essentially it's going to run through this list up here, and that's going to allow me to load in the relevant animation images. So now we can indent all of this within here. Now the next step you might have noticed is that I still have this idle text within here. So I'm still entering the actual folder name where the images are. I need to be able to make this easily controllable so that it can switch between idle and run depending on the variable that I'm in. So this for loop here is going to determine which folder I'm currently in. So just like I did with this image number here instead, where I just added in curly brackets, I can do the same thing. So I can remove this, add curly brackets, and then put in the animation variable. Now when this for loop is completed once, it's going to go on to a second time for the next animation. So that means that by the end of it, I'm going to load in 8 images. I'm going to load in 4 idle images and 4 run images. All of them are being stored in this animation list. Now the problem with that is that I'll end up with one list containing 8 images, but really there's not going to be an easy way to tell which images are associated with idle and which are associated with run. So what I actually need to do is split this up into 2 separate lists. I've put together a little diagram just to explain what it is that I'm going to try to do. So these are the images that are within the idle animation. So you can see when they're side by side, these are just still frames, but when we run through them quickly, we get that idle animation that we've already got working. And this is going to be our run animation. So the idea is that we want to create a list for each one of them, and then we want to store both of them in a bigger list. So our animation list up here is going to become almost like a master list that's going to contain being set these two different types of animations within it. Idle animation that we've already got working. Now I don't really need to differentiate between these two. I don't need to give them a name or anything like that. They're just temporary lists that are then getting added into my main animation list. So let's try and set up the structure here. Well, first of all, we need to create a temporary list. So within this first for loop, we'll add a comment to say reset temporary list of images, and my temp underscore list is becoming an empty list. So now I run through this section just as I did previously, but at the end, rather than adding it to my animation list, I'm going to add it into my temporary list. So temp underscore list dot append img. So once this for loop is completed, once it runs through 4 times, I'm going to have a temporary list, which on the first iteration is going to be this one. So it's going to have an idle animation inside it. So what I now want to do is take this list and append it inside my master animation list. So we keep this here, we unindent it once, and then instead of appending the image, we append this temporary list. So this eventually will become a list of lists. It's going to contain 2 lists inside of it. And what we can do just to demonstrate that is add a little print statement here. So we can say print animation list and run the code. Now it gives us an error because we haven't adjusted the rest of the code to interact with this new animation list, but the print statement should have still ran. And you can see it here. So you can see that there's one set of brackets for our main list, and then inside it is another set of brackets. And in there's 1, 2, 3, 4 images before that bracket closes. So that's one list. And then we have another list, 1, 2, 3, 4 images. So I know that the first 4 are idle, the second 4 are the run animation. So we can get rid of this. And now we need to work on this character class to be able to actually accept this new updated list. So let's go into the character class, and now we still receive an animation list, but it's just not quite the same as it was before. So that means that this line here that takes the current image, it says self.image is animation list at the index of frame index. Well, now I actually have a list inside a list. So if we go back to this diagram, what I need to be doing is first of all figuring out which of these 2 lists I want to target. So for example, if I want to look in the idle list, first of all, then I need to pass the index 0. So let's do that. So at the beginning we add index 0. So that means that I am now going into the idle animations. And then from there, I want to access the frame that I'm going to be looking at. So initially that's going to be frame 0. But as the animation progresses, we're going to move on to frame 1, frame 2, frame 3. But all within this first idle animation. So this is updated in one place. There is also another section which is within the update method where I'm calling self.image is equal to self.animation list. So I just need to add a 0 here to make sure that we're accessing the idle set of animations. And then lastly, this section here where I'm checking if the animations are finished. Well, I now need to also compare against animation list at index 0. So I'm putting zeros for now. This is just temporary, but I just want to make sure that first of all, this works with what should be my idle animation. So let's go back and run this code. Okay, there's no errors, and you can see we're getting the idle animation just as we were before, but we've added an extra layer here. So we actually know that there is a run animation stored inside here. So let's go back into the character class, and let's just change all this from 0 to 1, because we know that this next index, if we go back to here, this is index 0, this is index 1. So this should now give us the run animation. So if we fix it here, we fix it here, and we also change it here, we run this again, and now the guy is running. So it should currently be idle, but because we've set it manually to show us animation at index 1, it's showing us the run animation all the time. So that shows us how the process actually works, but we don't want to be manually putting in which type of animation it is we want to display. We want this to be automated, and we want it to depend on whether the player is idle or whether he's actually moving around with the keyboard. So for this, we need to add another variable. So just below this frame index, let's say self.action is equal to 0. And I'm just going to add a little note behind it to explain what each of the actions mean. So when it's set to 0, that means it's idle. And when it's set to 1, that means that it's running. So note, these just correspond to the index at the master list. So index 0 was idle animations and index 1 was the running animations. So now I can replace this here from a manual number to this variable instead. So we can set that to self.action. And we can do the same down in this animation update section. So that can become self.action. And then lastly down here, we change that to self.action as well. So let's just run this, make sure there's no errors. Okay, so it's gone back to the idle animation. Well, that means that for me to switch between idle and run, all I need to do is update this action. I just need a way of changing the action between 0 and 1, and that's automatically going to take care of the rest of the images. So to do that, we're going to create a little helper method, kind of like a helper function within this character class. So underneath my update method, but above the draw method, I will add a new method which will be define update underscore action. Now this will take the argument of self, but it will also take the argument of new action. So the first thing I want to do is actually check if the new action is different to what he's currently doing. So if he's already running and I'm telling him to run, well, there's no point changing the action. He's already doing that thing. So let's add a check to say, check if the new action is different to the previous one. So if new underscore action is different, i.e. is not equal to self.action, which is the current action, then we can update the action. So we can say self.action is equal to new action. But that on its own is not quite enough. So on the surface, that might seem like it will work, and most of the time it will. But remember, there are things that control the animation here, one of them being the frame index and the other being the update time. So if we were to change the action and therefore the animation, for example, halfway through an idle one, it's not going to reset back to 0 on the run animation. So we need to make sure that within here, we're resetting everything to start again. So we'll add a little comment to say, update the animation settings. So that if he's currently idle and then he suddenly begins to run, we want it to begin from the first index. So the first frame in the run animation. So self.frameIndex should be equal to 0. And the self.update time should equal to the current time. So that resets the timer for controlling this new animation that we've just changed into. So that would be pygame.time.get underscore ticks. So now that we've got this new helper method, we need to actually call it somewhere. And we're going to do that within the update method that we already have. So before we get into all this animation stuff here, we'll just make a little bit of space up here. And we'll add a comment to say, check what action the player is performing. Now the actions here are going to be either running or not running. So although I don't have this variable yet, we are going to create it in a second. So what we want to do is check whether the player is running. So we'll say if self.running is equal to true. Now remember, I don't have this variable existing yet, but we will create it. So if the player is currently running, well, what we want to do is call this helper method. Now because this helper method is part of the class, this update action, we add a prefix of self to be able to call it. So we say self.update underscore action, and I will call that helper method. Remember, it takes an argument, which is the new action that we want to perform. Well, if the player is running, then we want him to perform the running action. Now we go back to here where I added a little comment to explain what the numbers mean. Well, 0 is idle and 1 is running. That means that I need to update this action to 1. So that means he's going to be running. Well, if he's not running, so if that trigger is set to false, then we need to make sure that we set the action, update action back to idle, which is 0. And I'll just add little comments here just to make it a little bit more clear. So 1 is run and 0 is idle. But of course, before I run this game, I need to make sure that I've defined this variable here. So we go back up into the init method, into the constructor here, And let's just say underneath this update time section, we'll say self.running, and we'll start it off as false. So we'll run it as false, and let's just see if this runs. Self.running, and we'll start it off as false. So we'll run it as false, and let's just see if this runs. Okay, no problem. So it's running the idle animation. Now let's see if we can set it to true and see what happens. Now you can see he's running. So it's automatically updating the animation based on the player's action. The only thing left now is to actually make it so that it changes based on the keyboard inputs rather than manually setting this variable to true or false. So we'll begin with false, so he always starts off with the idle animation. And then we go just a little bit down here into the move method. So within the move method, we also want to make sure that we're resetting this variable. So we'll say self.running is false. So it always begins on the assumption that the player is not running, and then we check to see if he is. Well, this check is going to be done based on these two variables, dx and dy, because remember, this is what controls the speed. So if these are anything but 0, that means that there is some kind of movement going on. So we can just add an if statement here. If dx is not equal to 0, or dy is not equal to 0, so if he's moving in either direction, well, that means that he is moving. So self.running becomes true. So if we go back into the main game again, try and run it. So now he's in the idle animation, but as soon as I start running around, you can see he changes into his run animation. When I stop moving, he goes back to the idle animation. Now that we've set up the animations for the player, we're going to take this one step further and add in all the different animations for the different characters. We're going to use the same code as we already have, but we're just going to build on it a little bit to add this extra layer into it. So this slide I've updated to show how this is going to work. Now what you'd seen previously was just this green section here. It was the animation list for just the player. So it had two smaller lists inside it which contained all the images associated with it. Well, the other character types, they also have the same structure. They have an idle and a run animation, and each of those has 4 frames in it. So what I'm going to do is just repeat the process over and over for each different character type. I'll create an animation list for each one of them, and then I will combine all of those inside one master animation list, which is going to be this mob animations. So this orange one here is going to house all of my images inside it. Essentially, it's going to be like a triple nested list. So it's going to be a list inside a list inside a list. So let's go back to the code and see how to put this together. Now I'm still going to be using this section here, but I'm going to expand it a little bit. So I'll first of all add a comment to say load character images, and I first of all need to create this mob animations list. So this list here is master list. I need to first of all create that as an empty list. So we'll say mob underscore animations is equal to an empty list. I then need to put in the different mob types. So just like I did here with animation types, I'm going to create a list, mob underscore types, and I'm just going to list out each of the mobs, essentially each of the character names here that's going to tie into this folder structure. So the first one is the player. So I'm just going to start with elf because that's the one I use for the player. And then I'm going to list out all the other folders. So there is the imp folder, there is skeleton, goblin, a character called Muddy, there's a tiny underscore zombie, and there's a big underscore demon. So these names here, they tie in and they correlate with each of these folder names here. So the next step, you may have guessed from the previous video, is that we're going to nest all of these for loops inside yet another for loop, because now we need to iterate through this list here and load in all the images for each character type. So underneath my animation types, that stays as it is, I don't need to change that. I add another for loop. So I say for mob in mob types, so that I can now iterate through this list here. So let's indent all of this inside it. So for each mob, we're going to create an empty animation list. So that follows on from here. Each one of them is going to have an empty green animation list. So that part makes sense. And then within each animation, I'm going to create my temporary list, load in those 4 images, and I'm going to store them in that temporary list. However, there's one thing that we need to update here. So again, just as I did previously with these 2 variables, I need to be able to update this folder based on where we are within this for loop. So I actually need to replace the word elf with the variable mob. That way, each time we go through this for loop, we run through this list and we change the folder that we're loading the images from. Well, I've already shown you how to do this, so we're going to replace the word with these curly brackets, and inside here we're just going to put the variable name, which is mob. So by the end of all these loops, I'm going to have a bunch of animation lists for each one of these types of characters. But of course, I need to then store them inside this master mob animation list. So we go down here, we move back 1 level of indentation so that we're inside this for loop here, and we say mob underscore animations dot append animation list. So that takes care of loading in images. So this section here essentially runs through all of the files in the folders here, loads them in, and it gives us this one master list. So now when we create the player instance of this character class, we need to make sure that we're passing the right information through. So now we're actually passing in the mob animations instead. So mob underscore animations. But how do we know which of the animations this player is going to be using? Well, I need to be able to tie a particular number into this. So my mob animations list is going to be in the order of the mob types list. So index 0 is going to be the elf, 1 is going to be the imp, and so on. So all I need to do is pass another argument in here, which is going to tie into which type of mob I want this to be. Well, the player is an elf. So after mob animations, I'm going to add a 0 as an additional argument. Now I can go into my character class, and there's quite a few changes that we need to make here. First of all, at the top, we're no longer receiving the animation list. We're now receiving mob underscore animations, but we're also receiving an additional argument, which is the character type. So we'll just shorten this to char type. And now we just need to assign this to a self variable. So the character type is going to be equal to this variable, this argument that we've just passed in. And now our self.animation list, it's no longer this list that's being passed in, because we actually need to extract the correct set of animations from it. So we need to take that mob animations list and we need to access the index of the character type. char underscore type. So if it's the elf, then we need to make sure that we're taking this first set of images, and if it's the muddy character, then we need to take this set of images, and so on. So that's how we determine which set is going to be applicable, by using this character type variable. Now I think the rest should be okay, because the rest of the stuff is using the animation list variable. So we just need to add, I believe we need to change this to self.animationList. So the self.image is going to be taking from this new self.animationList variable, but the rest of it should stay as it is, because we already have a self.animationList here and down here. So let's just run this and see first of all if it works. Okay, so it still seems to be working correctly. We're still loading in the elf here. Now let's just try this by changing this to a 1 and see if it gives us a different character type. And there we go. Now we've got the imp. So it's changed to a different character. And if it changes to a 2, we should get a skeleton. And there we go. We've got a tiny little skeleton displayed there. And all the animations are working still correctly. So whenever he's standing about, he's in the idle, and whenever he's running around, he goes to the run animation. And that's because the way we set up this structure here from the ground up, we built in the facility to be able to change animations using the self.action trigger. So let's just reset this back to 0 so that we can load this in as the elf character. The next thing that I want to add in is a weapon for the player to use. So we go into this weapon.py file and we're going to create a class for the weapon. So we'll start off and we'll say class weapon, and then we'll create the constructor, which is the init method. So this is going to take the self argument, but it's also going to take an image argument, which is going to be the image that we use for the weapon. So normally I would say self.image is equal to image. However, in this case, because the bow is constantly going to be rotating around the player, I actually need to keep track of what the original image was. So I say self.original underscore image is equal to the image that we passed through. Then we have self.angle argument, which is going to start off as 0. And then we have the actual image that we're going to be showing on the screen. So self.image is equal to pygame.transform.rotate. And what is it that we're rotating? It's the original image by the new angle. So this is why I keep track of the original image. So as the game goes on, the angle is going to change. So we're going to always be taking our original image and we're going to be rotating it by that angle to generate a new image. And lastly, once we have this image created, we need to also create a rectangle. So we'll say self.rect is equal to self.image.get underscore rect. So this is going to take that image and create a rectangle from it. Now notice that I've called a pygame function here. So that means that I need to make sure that I am importing pygame at the top. So this weapon class for now is built. We've got a constructor here. So now we can go back into the main file and create an instance of it. So first of all, this is going to take the argument of image. So I need to make sure that I'm loading in an image here. Now we go up here just above this loading of the character images section, and I'll add a comment to say load weapon images. So the weapon I want is a bow, so it's going to be bow image is equal to, and just like we did previously, pygame.image.load, And then the image file and location is within the images folder, weapons, and bow.png. So it's assets / images / weapons, and it's bow.png. And then we just need to remember at the end to add .convert alpha. So that loads in the image. So we should now be able to create an instance of this class. But remember, before we can actually use this within the main file, we need to make sure that we import it. So up here we say from weapon, which is the name of the file, import weapon with a capital W, which is the name of the class. So now down here where we're creating our player, we can also create player's weapon. So we'll say bow is equal to weapon, and then the only argument it needs at the moment is bow_image. So let's just run this and see. Okay, so there's no errors, which means that in the background everything's worked correctly. We've loaded in the image, we've imported the module, and then we've created an instance of the bow. _image. So let's just run this and see. Okay, so there's no errors, which means that in the background everything's worked correctly. We've loaded in the image, we've imported the module, and then we've created an instance of the bow. Nothing is shown on the screen for it because we don't have an update or draw method for it. Okay, so there's no. So let's go back into this weapon file here and into the class. Now notice the first thing is that I normally pass in coordinates when I'm creating instances, but here we don't have X and Y coordinates. So this rectangle and this image aren't being positioned anywhere specific. Now that's because the position is always going to be updated based on where the player is. So the bow is always going to be centered on the player. So we're going to create an update method here, and it's going to take the arguments of self, and then it's going to take the argument of player. So we're going to pass the player into here, and the reason for that is so that we can position the rectangle. So we can say self.rect.center is equal to player.rect.center. So that's the update method. It's going to always position the bow at the player, and we need to also create a draw method. So we say def draw self, and the argument here is going to be surface, so that we know where to draw it. So we can just say surface.blit, and the image is going to be self.image at self.rect. So that's the weapon class initially built up. So let's go and just call these update and draw methods within our main game class initially built up. So let's go and just call these update and draw methods within our main game loop. So underneath where we're updating the player, we can say bow.update. But remember, it takes the argument of player into it. And down here we can say bow.draw, and it needs the surface. So let's just run this and see how it looks. Okay, so it's kind of worked and kind of not worked. So we've got a bow drawn up here. it's not quite in the right place for us, but we'll be able to build all this up as we go. Now the first thing we need to fix here is the fact that the player is not actually inside his own rectangle. He's kind of hanging on underneath it. So the bow is positioned in the right place because it's sitting in the rectangle, but the player isn't. Now the reason for that is actually the way the sprite is set up. So if I show you what the sprite looks like in an image editor here, you can see there's quite a bit of space above the top of the player. So because of this offset and because we're scaling the image in the game, the rectangle ends up being above the player. So what we need to do is add in a little offset to bring the player back into the correct position. So we go into our constants file up here, and I'm just going to add another constant variable, which is going to be offset. So I'll say offset, and I kind of played around with this previously, so I'm going to specify this as 12 pixels. Then we can go back into our character class, and right at the bottom where we're drawing the player onto the screen, or rather we're drawing any of the characters onto the screen, we're going to update this blit section here to use that offset. However, we only want this change to apply to the player. The other images, they are more or less inside their rectangles. It's just the player character, or rather the elf character, that seems to have this issue. So if the player is the one that we're trying to draw, then we want to add the offset. But otherwise, we're just going to draw it as is using this function here. So to add that check, we can say if self.characterType. Remember, this was an argument that we added previously that allowed us to determine what kind of character we're putting through from all those different images. Well, character type 0 was the elf, which is the main player. So if that's the case, then we're going to use a modified version of this blit function. But if not, then we're going to use it exactly as it is. So just up here, we're going to copy this up. So if it is the player, then we draw the flipped image, but we have to manually add in the coordinates here. So we add in another set of brackets, and the x coordinate, well, that's correct. So that's going to be the rectangle's x coordinate, but the y coordinate needs to be moved up the way. It needs to be offset. So we'll take the rectangle's y coordinate as it is, and then we will use that offset that we just added. So we'll say constants dot offset. But remember, the whole thing is being scaled. So actually I need to multiply the offset by the scale. So we'll say constants dot scale multiplied by constants dot offset. So if we run this again, I now get the player pretty much sitting in the middle of his rectangle. Now the rectangle position just now is kind of arbitrary. We'll come around to fixing that up properly when we add in the tile map. Offset that we just added. So we'll say constants dot offset. But remember, the whole thing is being scaled. So actually I need to multiply the offset by the multiplied by get the player. We'll come around to fixing that up properly when we add in the tile map and the levels. But for now, you can see that the player is sitting in the right place and the bow is nearly in the right place relative to the player. The next thing I want to fix is the size of that bow. So it's actually kind of small and you can hardly really see it here. So we're going to scale it up. Now we'll go back into the constants file. We already have one scale variable, but I don't want to use this exact same one. So I'm going to have another variable called weapon underscore scale. And this one is going to be 1.5. So I'm not going to scale this up quite as large as I scaled up the player. Now we can go back into the main file where we're loading the bow image up here. And just as soon as we load it in, we can wrap this entire section of code in this scale image helper function, which I've actually made a typo up here. It should be helper instead of helped. So we can wrap this by saying scale underscore image. The image itself, well, that's the image that's just being loaded here. So we keep that exactly as it is. And then the scale is going to be constants.weapon underscore scale. Itself, well, that's the image that's just being loaded. Scale underscore image instead of helped. So we can wrap this by saying scale underscore image. The image itself, well, that's the image that's just being loaded here. So we keep that exactly as it is. And then the scale is going to be constants.weapon underscore scale. So let's run this again. And you can see now the bow is quite a bit bigger than it was previously. Now the next thing we want to add in is rotation. So what I want to have happen with this bow is that as I move the mouse around, the bow always points at it. So we can go into the update method and add a little bit of functionality to that. Well, the first thing I want to know is where on the screen is the mouse sitting. So I can do that and store it inside a variable called pause for position. And this is going to be pygame.mouse.get underscore pause. This is just going to give me an X and Y coordinate on the screen for where the mouse is sitting. Then I can use these variables to work out the distance between the mouse position and the arrow, or sorry, the bow center. So we can say X distance is equal to pause at index 0 in mouse score called pause for position, and this is going to be pygame.mouse.get underscore pause. This is just going to give me an X and Y coordinate on the screen for where the mouse is sitting. Then I can use these variables to work out the distance between the mouse position and the arrow, or sorry, the bow center. So we can say X distance is equal to pause at index 0. So this pause has index 0 and index 1, which is my X and Y coordinates. So index 0 is the X coordinate minus self.rect.center X. So the middle or the X coordinate of the center of my rectangle. Then I can do the same thing for the Y distance. So we say the Y distance is equal to pause, but now it's pause at index 1 minus self.rect.center Y. And we have to wrap the whole thing in brackets and multiply it by -1, or rather just make it negative. So I'll add a little comment to explain why. As a reminder, it's negative because pygame Y coordinates increase down the screen. So essentially, whenever we have a positive value, it means that the mouse is actually below the bow and below the player. And now lastly, we can use this information to calculate the angle at which we need to rotate the bow. So we're going to be using math functions here. It means that I need to import math module. Now I'm not going to go into all the trigonometry behind this, but to calculate the angle, we say self.angle is equal to math.degrees math.atan to y underscore distance x x_distance. So this initial check here is going to give me the angle based on the y and x distances, but it's going to give it in radians. So then this section converts those radians into degrees. So now that we have this angle, we need to make sure that we're actually updating the image, we're rotating it by the angle. So we go into our draw method, and before we blit anything, we update the image. So we'll say self.image, and in fact, I think we can just copy what I've got up there. So self.image is just going to be the rotated version of the original image. So pygame.transform.rotate self.original image by self.angle. So let's just see if this works. Okay, so you can see as the mouse moves around, so does the bow. The bow rotates around the player. However, the rotation is a little bit wiggly. It doesn't go around it very smoothly. Now, the reason for this is the way that we're positioning the bow on the screen. It's trying to position around the center of the rectangle. So So what we actually need to do is slightly offset the bow image from its center line. So we're going to update this surface.blit section here. Now we're going to get rid of this self.rect for the positioning, and we're going to manually type in the x and y coordinates. So we'll add one set of brackets and then a second set of brackets. So within here we'll say self.rect.center x minus the integer value of self.image.get_width divided by 2. So that is our x coordinate. It essentially offsets the bow by half of the rectangle's width. And then we do the exact same thing for the y coordinate. So we'll say self.rect.center y minus the integer value of self.image. .get_height divided by 2. Okay, so let's try this now. Let me go back into the main file, run this again, and now you can see the movement. Let me go back into the main file, run this again, and now you can see the movement is a lot smoother, and so now the bow is actually rotating properly around the player. Now that the bow is set up and working, the next thing I'm going to add in is arrows for the player to shoot. So before we can do that, I need to load in images for the arrows. So we're going to come to this section here within the main.py file that says load weapon images. And underneath the bow image, we're going to say arrow_image is equal to well, I can actually just copy this down from the line above. And then we just change the file name and location here. So the file is within the same folder, assets, images, weapons, and then it's arrow.png. So we just rename this from bow to arrow. I keep the rest the same, and the scale is also going to be the same. So we're going to apply the weapon scale onto the arrow. So now we can go into this weapon.py module where we currently have a weapon class. Well, we're going to add the arrow class within here as well. So we'll say class arrow. And now normally I would just use empty brackets here. But for the arrows, I'm actually going to be using inheritance from pygame's existing sprite class. So that means that within these brackets, I need to add pygame.sprite.sprite. So notice that the first sprite has a small s, the second has a capital S. And that allows us to create the class. Then we create our constructor as normal. So this is the init method, and it's going to take the arguments of self, the image that we want to use, x and y coordinates, and then the angle at which the arrow is going to be fired. But now within the constructor, we also need to inherit the sprite class constructor. So we add another line here. We said pygame.sprite.sprite.init, and then we just put self as the only argument here. Now, if you've not seen this before and you haven't used these sprite classes before, then don't worry too much about it. At this stage, it's not actually going to change too much. The rest of the code is going to be very similar as if I wasn't using it, but it's just going to give me a little bit more functionality that I will explain when we come to actually use it. But for now, we just continue building up this constructor as normal. So we just want to assign these variables, these arguments that are being passed in into the class. So we'll say self.originalImage is equal to the image. So remember, because I'm going to be rotating this arrow, just the same as I did with the bow, I need to store the original image, and then I need to create a rotated version of that image. So we do that, then we assign the angle. So self.angle is equal to angle, and then we create the image. So, I'm just going to copy this from above here. So self.image is going to be the rotated version of the original image rotated by the angle. Then we use this image to create a rectangle. So I'll say self.rect is equal to self.image.get_rect to take the rectangle from it. And then we need to position it. So self.rect.center is equal to those x and y coordinates that we just passed through. Now I need a way of actually creating these arrows. So with my other classes, I create the instances of them within my main file. So for example, in here, I've created the player as the character class, and I've created the bow from the weapon class. But the arrows are actually going to be created whenever I shoot the bow. So they're going to be done within this weapon class here. This is what's going to be creating additional arrows. So we need to go into the update method here, and underneath all of this stuff that we've already got, which is essentially looking at the position and rotating the bow around the player, we're going to add another little section and adding the shooting functionality. Now shooting in this game is going to be done with the mouse. So first of all, I need to get mouse clicks. So let's say get mouse click, and that in pygame is done by saying if pygame.mouse.get_pressed. So this is going to return a list value, or essentially it's just going to return a bunch of zeros or ones depending on which mouse key you've pressed. Then we use this image to create a rectangle. So I'll say self.rect is equal to self.image.get_rect to take the rectangle from it. And then we need to position it. So self.rect.center is equal to those x and y coordinates that we just passed through. Now I need a way of actually creating these arrows. So with my other classes, I create the instances of them within my main file. So for example, in here, I've created the player as the character class, and I've created the bow from the weapon class. Create a rectangle. So I'll say self.rect is equal to self.image.get_rect to take the rectangle from it. And then we need to position it. So self.rect.center is equal to those x and y coordinates that we just passed through. Now I need a way of actually creating these arrows. So with my other classes, I create the instances of them within my main file. So for example, in here, I've created the player as the character class, and I've errors, which means that in the background everything's worked correctly. We've loaded in the image, we've imported the module, and then we've created the bow from the weapon class. But the arrows are actually going to create the instances of them within my main file. So for example, in here I've created the player as the character class, and I've created the bow from the weapon class. But the arrows are actually going to be created whenever I shoot the bow. So they're going to be done within this weapon class here. This is what's going to be creating additional arrows. So we need to go into the update method here, and underneath all of this stuff that we've arrows are actually going to be created we've already got, which is essentially looking at the position and rotating the bow around the player. We're going to add another little section and adding the shooting functionality. Now shooting in this game is going to be done with the mouse. So first of all I need to get mouse clicks. So let's say get mouse click, and that in pygame is done by saying if pygame.mouse.get underscore pressed. So this is going to return a list value, or essentially it's just going to return a bunch of zeros or ones depending on which mouse key you've pressed. So I want to know whether the left mouse button has been pressed. That means I need to access index 0. If you wanted to check if the right click has been done, then you change this index to 2, because index 1 is the middle mouse button. But for now I just need to know if the left mouse button has been clicked, and that is index 0. So if that is the case, then I want to create an arrow. So I can just say arrow is equal to an instance of the arrow class. And then I just pass in the images, I pass in the arguments that it requires. Well, the first one is the image. So that means that I need to be able to get the arrow image into the weapon class first of all, so that I can then pass it through into the arrow class here. So in the constructor of the weapon class up here, it currently takes its own image, which is the bow, but I'm going to add a second argument, which is arrow underscore image. Then we go back into the main file where we create this image. Then we go back into the main file where we create this bow in the first place, and we just add this second argument to make sure that they all equal out. So we take the bow image, but we also take the arrow image. So this image is actually going to be passed through a couple of times. It goes into the bow, but the bow doesn't use it. The bow then passes it through as an argument when it creates an arrow here. But for me to be able to use any of these arguments within the other methods, that means that I need to assign it as a self variable. That's what allows me to then use these within other sections of the class. So underneath this image here, I'm going to say self.arrowImage is equal to arrow image. So the arrow image that I am passing through here is being assigned to a self variable. So now I can use it within this section here within my update method. So that's the first argument that this needs. So we can pass that through here, self.arrowImage. Then it needs the X and Y coordinates. Well, we're going to be creating the arrows at the center of the bow because they're going to be fired from the bow. So for the X and Y coordinate, I can just take the rectangle position of the bow. So self.rect.centerX and self.rect.centerY. And lastly, I need to know the angle at which this arrow has been fired. Well, the angle is going to be the same as the angle of the bow, which has a self variable. So I can pass that through as my last argument, self.angle. Okay, so that's fine, but then it's just going to create these instances within its own update method. Nothing ever really happens with them, they just sit here. What I actually need to do is return them back into my main loop, or rather my main game. So from here, at the end of the update method, we just add a return statement. So we'll say return arrow. So whenever it creates an arrow. It's going to return it back into the game. But what if we haven't clicked anything yet? Well, then we're not going to run this section of the code. Therefore, an arrow is not going to be created, but the code is still going to want to try and return something. So we're going to get an error at this point. It's going to try and return something that doesn't exist. It's going to say that this variable has been called before it's been assigned. So in these cases, if something is not automatically generated, we need to make sure that we first of all declare this variable. So right at the top of this update method, I'm going to say arrow is equal to none. So first of all, there is no arrow. But as soon as the mouse is being clicked, we create an arrow, and that's what we return. If we haven't clicked, well, we just return this. We return nothing. So now we can go back into the main.py file, and we go to the section where the bow's update method is being called, which is down here. So previously it was just running on its own, but now we know that there's a return statement. So it's actually returning something back to us. And we can take that back by saying arrow is equal to this section here. So now whatever is being returned is being stored in this arrow variable. Now before I can test this and just make sure that everything's working, there is one more thing that I need to take care of just to avoid any errors. So whenever we click, we're going to be creating an arrow instance, and that's going to be returned here. But as we click multiple times, we're going to be wanting to create many different arrows. So how is that going to be handled? What's going to happen when this keeps returning additional arrows with new coordinates and different angles? Well, normally if I have multiple items, I would put them inside of a list, for example, like I have done in here. But because the arrow class, if I go back here, has been created as a pygame sprite class, this is where we can use some of that functionality to make things a little bit easier. So rather than adding it to a list, I'm actually going to use sprite groups. They operate quite similarly to a list, and the functionality you'll be able to recognize, but there are some useful features of it. So just underneath here where we've created the player and then we've created the player's weapon, but before we get into the game loop, we'll just add another little section and we'll say create sprite groups. And for now, the only group we have is the arrow group. So to create a group, we just say pygame.sprite.group. So notice the capital and small letters there. And now what we can do is go down to the section again where we're creating these arrows every time. And now what we can do is go down to the section again where we're creating these arrows every time we click and add them into this group. So first of all, I need to know if something has been returned. So I'll say if arrow, which essentially means that there's something has come back from that return statement and the value is not none. So that means that we've clicked, an arrow has been created, and then this section is going to be accepted. So in that case, we go into the arrow group and then we say dot add. So typically with a list you would say dot append, but with groups we would say dot add, and we add the arrow into it. And that's it. So the next time I click, another arrow is going to be created and then it's going to be added into this group. So this group over time is going to be built up with all of our arrows. So let's just test this out and see if we've got any errors along the way. So let's just print out the arrow group and run the code. Okay, so now it's staying at the bottom, group with 0 sprites. So if I click, now nothing's obviously coming up on the screen. I held it down for just a little bit and you can see now it says 6 sprites. So of course, we don't have a trigger or anything set up on the arrows. So as long as I hold the mouse button down, it's going to create more and more arrows. But you can see that that group is now filling up and it's holding all of those arrows within it. So that's good. We know that the arrows are being down to the section again where we're creating these arrows every time we click and add them into this group. So first of all, I need to know if something has been returned. So I'll say if arrow, which essentially means that there's something has come back from that return statement and the value is not none. So that means that we've clicked, an arrow has been created, and then this section is going to be accepted. So in that case, we go into the arrow group and then we say dot add. So typically with a list, you would say dot append, but with groups, we would say dot add, and we add the arrow into it. And that's it. So the next time I click, another arrow is going to be created, and then it's going to be added into this group. So this group over time is going to be built up with all of our arrows. So let's just test this out and see if we've got any errors along the way. So let's just print out the arrow group and run the code. Okay, so now it's saying at the bottom, group with 0 sprites. If I click, now nothing's obviously coming up on the screen. I held it down for just a little bit and you can see now it says 6 sprites. So of course, we don't have a trigger or anything set up on the arrows. So as long as I hold the mouse button down, it's going to create more and more arrows. But you can see that that group is now filling up and it's holding all of those arrows within it. So that's good. We know that the arrows are being created and they're being added into this group correctly. Now let's go back into the weapon when module and add a draw method here. So we'll go down below here. We know we're going to group with 0 sprites and it's created and add them into this group. So first of all, I need to know if something has been returned. So I'll say if arrow, which essentially means that there's something has come back from that return statement and the value is not none. So that means that we've clicked, an arrow has been created, and then this section is going to be accepted. So in that case, we go into the arrow group and then we say dot add. So typically with a list, you would say dot append, but with groups, we would say dot add, and we add the arrow into it. And that's it. So the next time I click, another arrow is going to be created, and then it's going to be added into this group. So this group over time is going to be built up with all inside of a list, for example, like I have done in here. As a pygame sprite class, this is where we can use some of that functionality to make things a little bit easier. So rather than adding it to a list, I'm actually going to use sprite groups. They operate quite similarly to a list, and the functionality you'll be able to recognize, but there are some useful features of it. So just underneath here where we've created the player and then we've created the player's weapon, but before we get into the game loop, we'll just add another little section and we'll say create sprite groups. And for now, the only group we have is the arrow group. So to create a group, we just say pygame.sprite.group. So notice the capital and small letters there. And now what we can do is go down to the section again where we're creating. So that means the arrow into it. And that's it. So the next time I click, another arrow is going to be created, and then it's going to be added into this group. So this group over time is going to be built up with all of our arrows. The arrow group is obviously coming. So of course we don't have a trigger or anything set up on on the arrows. So as long as I hold the mouse button down, it's going to create more and more arrows. But you can see that that group is now filling up and it's holding all of those here, and say define, draw, add it into this group correctly. Now let's go back into the weapon module and add a draw method here. So we'll go down below here and say define, draw, and the arguments again are just going to be self and surfaced. Now at this point I should actually mention that one of the features of the sprite class is that you don't actually need to create a draw method. I'm going to have to, because I need to modify how the sprites are drawn on the screen, but just to demonstrate this, I'm just going to comment this out for a second. So this class no longer has a draw method. In fact, I'll just delete it. And if we go back into the main loop here, so at the moment we're printing the arrow group, but underneath that, let's say arrow group dot draw, and then we have to pass in the screen variable. Now remember, I haven't created a draw method here. There's nothing here that refers to drawing anything on the screen, but because we've inherited this sprite class and we've called its constructor, any of the functionality that that sprite class had has been pulled through. So now remember, I haven't draw, and then we have to pass in, let's say arrow group dot draw, and then we have to pass in the screen variable. Now remember, I haven't created a draw method here. There's nothing here that refers to drawing anything on the screen, but because we've inherited this sprite class and we've called its constructor, any of the functionality that that sprite class had has been pulled through. So if we run this and I run around and I just start clicking, you can see it now draws the arrows. So these are the arrows that were being created as I was holding down the mouse button, but now because I've called this draw method, it's showing them up on the screen. So this is pretty handy, and we would use this if it wasn't for the fact that I actually need to modify the draw method slightly. So we're going to get rid of this and go back into the weapon class, or the arrow class, sorry, and create our own draw method. So we'll say define draw, arguments of self and surface. And the only reason I actually have to modify it is because I need to have the same blitting as functionality as I did up here in the weapon class. So remember, I had to offset it slightly. Normally when I blit stuff, I would say self.image and then the location would be self.rect. But in this case, I had to offset it based on the rectangle's X and Y coordinates by half of the image's width and half of the image's height. So I'm going to have to do the same thing for the arrows. So we just copy this line down, but this is why we can't just use the group.draw method. So we copy this down here. Now we can go back into our main file and we print the arrow group into our main file, and we can actually just get rid of this now. We don't need to print the arrow group. And down here where I'm currently drawing all of my sprites, so I'm drawing the player and I'm drawing the bow, I'm going to say, well, I need to iterate through that group now. So I'll say for arrow in arrow group, arrow dot draw onto the screen. So if we run this again, I should now be able to run around and create these arrows wherever I click. So that's kind of working fine now, but the problem is that around and create these arrows wherever I click. So that's kind of working fine now, but the problem is that as long as I hold the mouse button down, I can just create a whole bunch of arrows and just leave this big stream behind me. So I need to add some kind of trigger to make sure that I can only click one at a time. So we go back into this weapon module and into the weapon class. And down here, we're just going to add a trigger. So we'll say self.fired is equal to false. Now I can add an additional check to this mouse click section. So I can say if the mouse has been clicked and self.fired is equal to false. So as long as that trigger is not true yet, then we can create an arrow. But as soon as we have done that, we want to set that trigger back to true. So we'll say the self.fired now becomes true. Okay, so let's run this and see what happens. So now I can click once and there you go, there's one arrow, but now I can click again and there's no more arrows appearing. Now, the reason for that, of course, is that I'm not resetting this back to false. So this can never run a second time. So that means that we need to have a trigger, or essentially a condition that sets this trigger back to false. Well, that's just going to be when I release the mouse button. So we can look for the opposite. So I'll just add a little comment here to say reset mouse click. And I can say if pygame.mouse.get_pressed. So exactly the same as above at index 0, but now I'm looking for it to be false. So basically I'm saying now that mouse button is not pressed. So if it's not pressed, then the trigger can be reset back to false. Okay, so let's go back and run this again. So now I can click once, let go, click again, and there we go. Every time I click, I'm now creating just one of these arrows. Now let's just check one more thing. So you notice so if it's not pressed, then the trigger can be reset back to false. Okay, so let's go back and run this again. So now I can click once, let go, click again, and there we go. Every time I click, I'm now creating just one of these arrows. Now let's just check one more thing. So you notice I'm pointing up the way, but the arrow is pointing to the left. I'm pointing to the right, the arrow points up the way. Point down, the arrow points there. It always seems to be 90 degrees out. And that's just because of the way the sprite itself was orientated. So there's just another little check or another little condition I have to add into this arrow class here. So when we rotate the original image and we create this self.image, well, we just subtract 90 degrees from the angle. If we run this again, so I'll point up, and there we go, the arrow is pointing up the way, and the arrow is pointing down the way. Okay, so it's starting to come together. There's another little issue that we need to fix though, which is that although, yes, I can only click once, I can also kind of just spam it. So as long as I can click really quickly, I'm going to create a whole bunch of arrows still. So I kind of want to have a little bit of a reload time essentially, so that the player can only fire every, I don't know, every 300, 400, 500 milliseconds or so, just to make it a little bit more of a challenge and you can't just spam these arrows. So we go back into this weapon module and into the weapon class, and I'm going to add yet another variable here. So we'll say self.lastShot, and we're just going to take a timestamp. So we're going to check what time was it when we last fired something. So we'll say pygame.time.get_ticks. So the reason we have this within the constructor is that as soon as we create an instance of this bow, we look at what time it was, and that's going to reset the timer from there. So now within this update method, I need to add another variable called shot cooldown. So we'll set this to 300, and that's going to be our milliseconds. This actually is going to be quite similar to how the animations are handled. I basically look at how much time has passed, and if it's greater than the shot cooldown, then we can reset and we can go again. So we add another condition into this if statement here. So first of all, it's saying if the mouse button has been clicked, yes, and self.fired, this trigger is false. Okay, and then let's add another check. And so we'll just put brackets here, pygame.time.get_ticks. So what is the current time minus the time when the last shot was fired. If that is greater or equal to our cooldown that we specified, then we can take a shot. So then it's okay, we can continue, we can take another shot. But remember, we need to now reset the timer. So we'll say self.time.get_ticks. So what is the current time minus the time when the last shot was fired. If that is greater or equal to our cooldown that we specified, then we can take a shot. So then it's okay, we can continue, we can take another shot. But remember, we need to now reset the timer. So we'll say self.time. If that is greater or equal to our cooldown that we specified, then we can take a shot. So then it's okay, we can continue, we can take another shot. But remember, we need to now reset the timer. So we'll say self.last_shot. Well, the last shot has happened right now. So what is the time right now? It's pygame.time.get_ticks. Okay, so let's try this again. We go back here, .time. .get_ticks. Okay, so let's try this again. We go back here, and I'll just try and click as fast as I can, but you notice it's only creating them at kind of fixed intervals, if you like. And you can play around with this variable here. So if I set this to I don't know, like 1000, then that's going to mean I can only fire one arrow every second. So you can see there's quite a long delay. Although I'm clicking, you maybe can't hear it, I'm clicking quite a lot. I'm only firing once every second. So let's go back, that's a little bit too slow. Let's set this back to 300 milliseconds. So we're slowly getting there, but of course the problem is that these arrows are completely stationary. So they just stay wherever they are fired from. What we now want to add in is movement. We want to work out which direction they're going to be moving in, and based on that work out their dx and dy values so they can move along the screen. So let's go back into the weapon class here, or rather the weapon module and the arrow class, and work out this movement speed. So within the constructor, just underneath here, I'll add a little comment to say calculate the horizontal and vertical speeds based on the angle. So this can be done within the constructor because the angle is defined at the moment when we first click and we create the arrow. So from that point, it's just going to move on that fixed trajectory. So we set this up at the constructor, and then the update method just moves it along at that speed. Now you're going to be familiar with these two variables already because we used dx and dy variables for moving the player around. Those dx and dy variables were essentially his speed in the x and y coordinates. So I'm going to assign the same for the arrow. So we'll say self dx is equal to, well here again I need to use a bit of trigonometry because we need to work out based on the angle how that's going to translate into the dx and the dy speeds. So there's going to be a couple of steps here. First of all, we need to work out or rather we need to convert the angle into radians. So we say math.radians of self.angle. Let's just double check, because I'm using the math module, let's just double check I've imported it. Yes, I have. I've used it previously. So we can continue with this. Now we've got this converted into radians. The next thing is to calculate the cosine. So we'll say math.cos, and we wrap all of this within another set of brackets. And lastly, we want to multiply this, the entire thing, by the speed that the arrow is going to be moving at. Well, we haven't actually defined that yet, so we'll go into this constant file, and let's see, we've got the player speed here, so just underneath that, let's say arrow underscore speed, and we want this to move pretty fast, so let's set it to 10 pixels. So now let's go back here and say multiplied by constants dot arrow speed. And now I can do the same thing for dy. So self.dy is going to be, well, first of all, convert to radians. So math.radians of self.angle. And now this time we're working out the sine value, not the cosine. So we'll say math, wrap this up in brackets. So it's math.sine of this variable here. And then again, we have to multiply that by our speed. So constants.arrow speed. But then lastly, remember, because the y coordinates in pygame are flipped, meaning that 0 is at the top and it moves down the screen, so it increases as it goes down the screen, we're going to have to flip this variable as well. So we're going to have to add a negative at the beginning here. And I'll add a little comment at the end just to explain why we've done that. So it's negative because pygame coordinates, well, let's say pygame y coordinate increases down the screen. Okay, so we've worked out the speed, but now we need to actually have a way of moving the rectangle based on this speed. And this is where our update method comes in. So we're going to create an update method here. And for now, it just needs to take the self argument. It doesn't need to take anything else, because the dx and the dy variables, well, they're already self variables. And we'll just add a comment here to say reposition based on speed. So essentially all we're going to do is take the self.rect.x coordinate and we're going to increase it by self.dx, and then we do the same thing with our dy variable. So self.rect.y is increased by self.dy. So now let's go back into the main file and make sure we're actually calling that update method. Well, this is the section where we're updating everything. So we've got player.update, arrow, well, bow.update, and then we add arrows into our group. So underneath that, we can now iterate through the arrow group. We can say for arrow in arrow group, and we just want to update each of the arrows. So arrow.update. So let's just run this and see if it works. And it doesn't. So what have I done? I've made a typo. I see. I thought I was already using constants within this class up here, but I guess I wasn't. So I need to, of course, make sure that I'm importing that. So we'll import constants. So let's go back up here, try this again. Okay. This class up here, but I guess I wasn't. So I need to, of course, make sure that I'm importing that. So we'll import constants. Let's go back up here, try this again. Okay, and there we go. So now you can see that as I run around and I'm aiming wherever I want, I can shoot these arrows off in every direction. There is, however, one little thing that we need to fix, and it's not immediately obvious. So what we'll do is we'll go back into here and we're going to bring that print statement back in. So we'll say print arrow group. So this is going to show us how many arrows there are within this group. So if I fire, there's 1, there's 2, there's 3. So I can keep firing them, but notice there are no arrows anymore. They've all gone off the screen, but this is still showing 9 sprites. So if I keep playing this game and I keep shooting, I'm going to end up creating a whole bunch of arrows that are within this group, but I can't see them anymore. I'm going to end up creating a whole bunch of arrows that are within this group, but I can't see them anymore. So as far as I'm concerned, they don't exist. Well, in reality, they do exist. They basically just keep going off the screen forever. So although they're not shown here, that arrow that's gone, well, that's got coordinates that just exceed the screen, and it's just going to keep going forever. So actually what I need to do is make sure that when the arrow goes off the screen, it gets deleted. We don't want to keep it anymore. We don't want to take up memory with arrows that aren't there. So let's go back into our arrow class down here. And within the update method, after we've moved it, so after we reposition based on speed, we're just going to do a little check. So we'll say check if arrow has gone off screen. And this check is going to be fairly straightforward because we know that the arrow has a rectangle. We've created that rectangle earlier. And the rectangle has got, well, it's got properties of left, right, top and bottom. And those essentially determine where each of those points on the rectangle are. So we can just check if those have gone off the screen. So let's just type them out one by one. If self.rect.right, so if the right hand side of the rectangle has gone off the left hand side of the screen, so remember x coordinate of 0 is going to be the very left hand side of our game window. So if the right hand side of the rectangle has gone below that, it means that the entire rectangle is off the screen. So that's one condition, that's for going off the left hand side. So what happens if we go off the right hand side? Well, then we check for the rectangle's left edge being greater than our screen width. So that comes from constants, screen width. So that's left and right taken care of. Now let's do top and bottom. So we say or self.rect.bottom is less than 0, which means that we've gone off the top of the screen. Remember, the y coordinate of 0 is at the top. Or what if we've gone off the bottom of the screen? Well, then it's self.rect.top is greater than constants.screen height. So if that condition is met, or well, if any of those conditions is met, that means that the sprite or this image has gone off the screen completely. So we just want to get rid of it. We want to drop it out of memory. Well, this is another useful feature of sprite classes and groups. We can just say self.kill, and that's going to kill that item from the group. It's going to delete the instance and it's going to drop this number. So let's go back and run this again just to test it out. So 0 sprites, let's just shoot a few. And you can see it increases them and then it starts to count down. So I shoot 1 and drops to 0. Shoot 1, drops to 0. I can spam a few of them, but it never really goes beyond about 3 because that's about as fast as I can shoot them. 4, 3, 2, 1, 0. So now we can get rid of this temporary print statement, and that is our arrows working correctly. Now that the arrows are are working correctly, the next thing to do is add something for the player to shoot at. So I'm going to create an enemy. I'll give the enemy health, and then I will modify the arrow class a little bit to be able to check for collisions between the arrows and the enemies. Now the enemies are created in the same way as the player. So if we go down here within this main.py file, we have a little section here where we create the player. So if I go back into the character class, just as a reminder of how it was structured, it takes a few different arguments. So it's the X and Y coordinates, then this mob animations list, which remember is just a full list of all the individual sprites that we're going to be using for the characters and the enemies. And then lastly is the character type. And this determines which type of character it is, and it correlates back into this list here. So that means that to create an enemy, I just follow the same format as I did for the player. So underneath this line here, I'll create another little section and I will say create enemy. And I will say enemy is equal to character, so it's an instance of the character class. Then I need to give it X and Y coordinates. So let's say 200X, 300Y. Then I pass in that mob animations list, and then the last argument is going to determine which type of character I want from this list. Well, 0 is the elf, that's the player. So let's just go to the next one. Let's just go number 1, and that's going to create the imp character. So this will give us one individual enemy, which is fine for now. But as the game progresses, I'm going to have a whole bunch of different enemies within each level. So when I have more than one of an object, I like to store them in some way, and typically I would use a list like I have done here. So although I only have one enemy for now, I'm going to just set that up anyway. So down here where I have a section for creating my sprite groups, well, just before it, I'll have another little section where I create empty enemy list. And this will just be called enemy underscore list, and it's going to be an empty list, which means I put a set of empty square brackets here. So now what I can do is I can add this enemy that I've created into this list. So we'll say enemy underscore list dot append enemy. And later on we're going to automate this so that we can generate a whole bunch of enemies and automatically put them into this list. But by setting it up this way from the start, it just makes it easier down the line. Because we're using the character class again, it actually means that a lot of the functionality we're going to need for this enemy already exists. So within the character class, we already have a move method, an update method, and update actions, and a draw method. So I don't need to go and recode all of this again. So this is kind of the benefit of setting up things with the classes. So we go back into my main file, and we need to make sure that we call those methods now on this enemy object. So within this main while loop, I'll go down and see, so I have my section for moving the player. Well, I don't want to apply this to the enemies because the controls here are only applicable to the player. If I add this to my enemy as well, then whenever I press these WASD keys, the enemy is also going to move. So enemy movement is going to be captured separately further down the line. But for now, we want to update the enemy. So just up here, we'll say enemy. In fact, no, I need to iterate through. So although I only have one enemy for now, I will have more in the future. So I'm going to iterate through them one by one. So we'll say for enemy in enemy list. By one. So we'll say for now, I will have more in the future. So I'm going to iterate through them one by one. So we'll say for enemy in enemy list, enemy.update. So at the moment, it's only going to do this once, but when I have a larger enemy list, this will just make sure that it's automated and every enemy runs its update method. So that takes care of the update. Now we come down here and we do the same thing again. We'll say for enemy in enemy list, enemy.draw onto the screen. Okay, so let's run this and see what happens. And there we go. So you've got the player up here, but we now also have this little imp character as well. Now you can't move around, you can't do anything because he doesn't have any AI yet, but we can see that it's loading in properly. The next thing we want to do is now give these enemies some health so that we can shoot them and see if their health goes down. So we go back into the character class and I actually have to modify this constructor up here. So after my X and Y coordinates, I'm going to add another argument in between here. So this argument is going to be called health. And now somewhere down here, maybe below this self.running variable, we can say self.health is equal to health. So that whatever I pass through here gets assigned to the object. And I'm actually just going to space out these sections because this is the part where I take care of the image. So I'm going to keep that a little bit separate from all these variables up here. But now that I'm expecting a health argument within the constructor, well, it means that I need to go back and anytime I use this character class, like I did here and Well, it means that I need to go back and anytime I use this character class, like I did here and here, I need to make sure that I pass this argument in. Otherwise, there's going to be an error because they're not going to be balanced. I'm not going to be passing in enough arguments. So in between this, after these X and Y coordinates, I need to add in a health. So I'm just going to give 100 health as a default. So the player will start with 100 and the enemy will start with 100 as well. And what we can do as a little test is go down and just print out the enemy's health. So we go back into this game loop and somewhere down here, just after all the updates and the draws, I'm just gonna, because it's enemy will start with 100 as well. And what we can do as a little test is go down and just print out the enemy's health. So we go back into this game loop and somewhere down here, just after all the updates and the draws, I'm just gonna, because it's temporary, I'm just gonna add its own little section here so I know why to delete it. And we'll just say print enemy dot health, delete it. And we'll just say print. Now that the bow is set up, print enemy dot health. Now I don't have to iterate through the list because I know that there's only one enemy object and I've already created it, and this part here is temporary, so I don't really need to worry about making it a bit more proper than this. So if we run this now, you can see it's giving me 100. So that's how much health this guy has at the moment. So now let's do a check between the arrows and the enemies to see if we've done any damage to them. So we go back into this weapon module and go down to the arrow class. And just down here in the update method, just below where we're currently doing a check to see if the arrow has gone off the screen, we're going to add another section, and this is going to have a note to say check collision between arrow and enemies. Well, to be able to do this, I actually need to iterate through every one of the enemies. So that means that I need to go through the enemy list. But the enemy list doesn't exist within this module here. I have to either import it or I have to pass it in as an argument. Well, in this case, it makes sense to pass it in as an argument to the imported or method. We're going to add another one that so what is an argument? Well, in this case, it makes sense to pass it in as an argument to the update method. So what we're going to do is after the self argument here, we're going to add another one that says enemy underscore list. So of course, to avoid any errors, we go back into the main file and look for where we're calling this arrow update. And it's file and look for where we're calling this arrow update. And it's right down here. So for each arrow in the arrow group, we call the arrow update method. Well, now we actually need to pass the enemy list into it as an argument. So now we go back into the arrow class again, and we're now taking this enemy list here as an argument. So we go back down to this section and we can now iterate through it. So we can say for enemy in enemy list, and for each of these enemy method _, makes sense to pass it in as an argument to the enemy list. But the enemy list doesn't exist within this module here. I have to either import it or I have to pass it in as an argument. Well, in this case, it makes sense to pass it in as an argument to the update method. So what we're going to do is after the self argument here, we're going to add another one that says enemy _ list. So of course, to avoid and for each of these enemies, we want to check for collision between their rectangle and the arrow's rectangle. So this can be done by referencing the enemy's rectangle. So we'll say if enemy dot rect, and then we'll call the function collide rect. So this essentially just takes two rectangles and checks if they are overlapping. So it saves us a little bit of work, but we need to pass an argument into this function. So the argument is going to be what rectangle do I want to check for collision with? So I'm taking the enemy's rectangle and I'm checking for collision against the arrow rectangle. Well, I'm currently in the arrow class, so the arrow's rectangle is just self.rect. So if this condition is true, i.e. there is a collision between the arrow and the enemy rectangles, then I want to first of all calculate how much damage I'm going to do and then apply that damage to the enemy. So to calculate the damage, I'm going to say damage is equal to, and I'm just going to randomize it a little bit. So I'll pick a number first of all. I'll say 10 as a base number, and then I will use the random module. So I'll say plus random dot rand int, which is going to generate a random integer between -5 and +5. So this basically means that we can do damage anywhere between 10 -5, so 5, or 10 +5, so 15. So anywhere between 5 and 15 damage. So it just adds a little bit of randomness to this this game. But of course, now that I've used this random method here, or this random module and its function, I need to make sure that I am importing it. So we go right up to the top, and just below where we import math, I'm going to import random. So with that damage calculated down here, we now need to apply that damage to the enemy. Well, because we're already iterating through the enemy class and we're checking for each particular enemy here, we can actually apply it directly to them. So we can call up the enemy object and we can access its health variable and just subtract the damage that we've done. So that's going to reduce this variable here. It's going to reduce the health of that particular enemy. Now, once that's happened, we want this arrow to stop. So we don't want the arrow to continue moving and potentially hit another enemy. So to get rid of the arrow, remember, just as I did up here, where I checked if it goes off screen, we apply this self.kill. We're going to do the same thing here. So we'll say self.kill, and that one arrow then is deleted. But in addition to this, because we're currently in a for loop, as soon as this condition is met and the arrow has made contact with one of the enemies, there's no point in continuing to check with the other enemies because we know that it's happened and the arrow therefore is over. So in here, we're just going to add a break statement, and that will get us out of this loop and essentially stop us continuing to check the remaining enemies. So now let's go back to the main file and just see if this will run without any errors. Okay, so it runs fine, and now let's just shoot an arrow here. So I missed the first couple, and keep attention. Pay attention to this, and the one arrow self. Get rid of the arrow here, and push. So with that damage, just below where we import math, I'm going to use and import a bit of random 10 do damage between the base number, and I want there is a collision. So if this condition is true, rectangle is just i.e. there is a collision between the arrow and the enemy rectangles, then I want to first of all calculate how much damage I'm going to do and then apply that damage to the enemy. So to calculate the damage, I'm going to say damage is equal to, and I'm just going to randomize it a little bit. So I'll pick a number first of all. I'll say 10 as a base number, and then I will use the random module. So I'll say plus random dot rand int, which is going to generate 15 damage. Now that I've made here to the enemy, so so to self.kill, we're going to do the same thing here. So we'll say self.kill, and that one arrow then is deleted. Mission is the other here. We're just check the remainder and pay attention to the numbers on here. So now one way that we could fix this is add an if statement. So we can say that if the enemy health has gone below 0, then we just reset it back to 0. But we're actually going to do it one step further. So we'll go back into the character class here and add an additional variable. So let's say where we've got our health variable, we'll say self.alive is equal to true. So when the instance is first created, well, that enemy or that character, that player is alive. So we'll start with this variable set to true. And now we can add another little check if we go down into our update method here. And just before we go into the actions, we'll add a little check on health. So we'll say check if character has died. And this check is just like I described. We look for the current health and we see if it's below 0 or not. So if self.health is less than or equal to 0, well then we set that health to 0, so we don't want to display a negative number. But in addition to that, we want to register that that character has now died. So self.alive is no longer true, it now becomes false. What's the benefit of adding this second variable? Well, if we go back into the weapon class, the arrow class within the weapon module here, we're going to add that as an additional check in this collision. In the second variable, well, if we go back into the weapon class, the arrow class within the weapon module here, we're going to add that as an additional check in this collision section. So at the moment, the only check we're doing is to see if the rectangle of the arrow and the rectangle of the enemy have overlapped. But if that enemy has died, this condition could still be met. So we could still be firing arrows into an enemy that's already dead. Its health will stay at 0, but the arrow will be wasted. So we're going to add an extra check here. So we'll say, as well as a rectangular collision, we also need to make sure that the enemy is alive. So we say if enemy dot alive. So now if both of these conditions are true, then we will take damage, or the enemy will take damage. But if not, the arrow should just pass straight through. So let's go back and run this again. And I'll just shoot this guy a few times, drop the enemy's health to 0. Okay, so it's 2, and now it goes to 0, and now the arrow passes straight through. So the enemy is now dead. He's still bobbing around, the animation is still running, but we'll deal with that later on. But for now, we can register the fact that the enemy's alive trigger must have been set to false, and the arrows are just passing straight through. Now, although we've got the arrows working correctly, and we can see that it's registering damage to the enemies, the player's not actually getting any feedback here. So we're not going to be using print statements in the actual game. So what I would like to add is a way of being able to see how much damage this enemy has actually taken when the arrow has hit him. So what I'm going to do is create a new class which is going to take care of our damage text. So we'll go up here somewhere, so just after we load in all of our images, but before we start creating instances, I'm going to have a little section here where I'm going to add a new class. So this class is quite small, which is why I'm not putting it in a separate module of its own. I'm just going to keep it here within the main file. And this will be the damage text class. So I will say class damage text, so the D and the T are capitalized. And now this is also going to be a sprite class. So it needs to inherit from pygame's sprite class here. And that means that we need to add in pygame.sprite.sprite. Then we create the constructor as normal. So we'll create the init method with, just for now, the self argument. And then of course, because I want this inheritance, I want to add in here pygame.sprite.sprite. And we need to add in the init method from the sprite class. So how's this damage text class going to work? Well, essentially it's going to take the number, which is the damage that has been dealt. It will turn it into an image and it will blit that image onto the screen for us. So we need to add in a few arguments here. So at the moment, the constructor doesn't have anything in it. But first of all, I need to know where I'm going to position the damage text. So we'll give it X and Y coordinates. We also then want to know how much damage has been dealt. So we'll add the damage variable. And then lastly, I'm going to add the color variable here. So what color do I want to display this in? So now that I have these, I need to make sure that I assign them to the class. So say self.image is equal to, well, like I said, I'm going to take this damage variable and turn it into an image. So there's a way of doing this within pygame. So you can't just take text and display it on the screen, because you've noticed every time I've put print, it goes down here. It doesn't actually come up in the game window. But before we convert that text into an image, we need to first of all define the font that we're going to be using for this. So that's going to be something that will be defined as a variable. Now I'll go back up here and let's see, where's the best place to put it? We'll just put it underneath these movement variables. So I'll add a section and I'll say define font with a comment, define font, and then font is going to be equal to pygame.font with a capital F, and then I just need to load it in. So I need to give it the file name and location, just like I've done with all my other assets. So if we go back to the folder structure here again, we have assets, then there's a folder called fonts, and then I have a font that I want to use here. So we just need to navigate to it. We'll say assets /fonts /Atari classic.ttf. And then the second argument is how big the font needs to be. So I'm just going to say we'll give it a font size of 20. Now using this font, I can go back into my damage text class and I can use that font to convert the text into an image. So we'll first of all say font, then we'll call the render function. And in here, there's a few arguments. So the first argument is how much, or rather, what is the text that I want to display? Well, the text is the damage. So then the amount of damage that's being done is being converted. Then the second argument we set to true. And the third argument is what color we want this to be displayed in. Well, that's also being fed in here as an argument. So we'll put in color there. So that'll be the image created. And of course, we need to convert, or we need to create a rectangle from it. So self.rect is self.image.get_rect. And then we need to position that rectangle. So self.rect.center is at coordinates X and Y. So that's all of these arguments now used up. So for now, this is all the functionality that I want in it. We'll build up on it a little bit more in a second, but let's just see if this actually works. So we've got the class created, and that means we need to create an instance of it. Now those are going to be created automatically anytime we shoot an enemy and we make contact. Of 20. Now using this font, I can go back into my damage text class and I can use that font to convert the text into an image. So we'll first of all say font, then we'll call the render function, and in here there's a few arguments. So the first argument is how much, or rather, what is the text that I want to display? Well, the text is the damage, so then the amount of damage that's being done is being converted. So to be a sprite object I'm inheriting from the sprite class, I'm going to be using groups again, just like I did with the arrows. So just before the arrows here, I'm going to say damage_text_group is equal to pygame.sprite.group. And now let's just create, so I'll make a big section here so I can easily find it later to delete it. And I'll just say temporary damage text. So we'll just put this on the screen, we'll just create it so that we can test it's working correctly. And I'll just say damage text is equal to, it's an instance of the damage text class. I need to give it the arguments that it was asking for. First of all was the X coordinate, so let's say 300, 400 on Y. Then it wanted damage, so let's just say 15 damage, and then a color. Well, our colors are stored in the constants file here, so it would be constants. We'll go with red, constants dot red, and then once this is created, I need to add it into my group. So I will say damage text group dot add damage text. So now remember, because this is inheriting from the sprite class, we automatically have an update and a draw method. So we can just go back down into the main class, we automatically have an update and a draw method. So we can just go back down into the main game loop, and where we currently have our arrows being updated, just underneath that, but not indented, so it's not going to be within the for loop, it's outside of it, we can say damage text group dot update, and then down here we can say damage text group dot draw onto the screen. Okay, so let's just test if this works. We'll run this, and I've made a typo somewhere. Of course, I was putting that together a little bit too quickly. So within this section here where I render the text to an image, well, this needs to be a string, but of course I've just passed it a number. So it shouldn't be a number of 15, it should be a string that says 15. So let's try that again. Indented, so it's not going to be within the for loop, it's outside. Together a little bit too quickly. So within this section here where I render the text to an image, well, this needs to be a string, but of course I've just passed it a number. So it shouldn't be a number of 15, it should be a string that says 15. So let's try. If this actually works. So we've got the class created. Of course, because I want this inheritance, I want to add in here pygame.sprite.sprite, and we need to add in the init method from the sprite class. So how's this damage text class going to work? Well, essentially, it's going to take the number, which is the damage that has been dealt. It will turn it into an image, and it will blit that image onto the screen for us. So we need to add in a few arguments here. So at the moment, the constructor doesn't have anything in it. But first of all, I need to know where I'm going to position in the damage text. So we'll give it X and Y coordinates. We also then want to know how much damage has been dealt. So we'll add the damage variable, and then lastly I'm going to add the color variable here. So what color do I want to display this in? So now that I have these, I need to make sure that I assign them to the class. So say self.image is equal to, well, like I said, I'm going to take this damage variable and turn it into an image. So there's a way of doing this within Pygame. So you can't just take text and display it on the screen, because you've noticed every time I've put print, it goes down here. It doesn't actually come up /TTF. And then the second argument is how big the font needs to be. So I'm just going to say we'll give it a font size of 20. Now using this font, I can go back into my damage text class and I can use that font to convert the text into an image. So we'll first of all say font, then we'll call the render function, and in here there's a few arguments. So the first argument is how much, or rather what is the text that I want to display. Well, the text is the damage, so then the amount of damage that's being done is being converted. Then the second argument we set to true, and the third argument is what color we want this to be displayed. In. Well, that's also being fed in here as an argument, so we'll put in color there. that'll be the image created, and of course we need to convert, or we need to create a rectangle from it. So self.rect is self.image dot get underscore rect, and then we need to position that rectangle. So self.rect.center is at coordinates x and y. So that's all of these arguments now used up. So for now, this is all the functionality that I want in it. We'll build up on it a little bit more in a second, but let's just see if this actually works. So we've got the class created, and that means we need to create an instance of it. And then a color. Well, our colors are stored in .red damage text group .add damage text. So now remember, because this is inheriting from the sprite class, we automatically have an update and a draw method. So we can just go back down into the main game loop, and where we currently have our arrows being updated, just underneath that, but not indented, so it's not going to be within the for loop, it's outside of it, we can say damage text group dot update, and then down here we can say damage text group dot draw onto the screen. Okay, so let's just test if this works. We'll run this. And I've made a typo somewhere. Of course, I was putting that together a little bit too quickly. So within this section here, where I render the text to an image, well, this needs to be a string, but of course I've just passed it a number. So it shouldn't be a number of 15, it should be a string that says 15. So let's try that again. A number of 15. It should be a string that says 15. let's try it. So in a typo somewhere, you can text group be within the. I just go back down into the main damage group constants.red. So pre-sprite or a sprite object. So just before the arrow, kind of later to do. And now let's just create a group object DAG of it. Now this is an arrow argument. So we'll put in color there. Display to display. So I'm just going to using that on with equal to levels. Let's see where's the best will be defined as a variable. Find the font that we're going to be using before doing those in variable. Lastly, I'm going to add the color variable here. So what color do I want the class? Like I said, way every but we're going to just put it underneath define going F. Like I've asked, would you F say text class how much the third argument or we need of so one in it the class listed out let's using groups damage underscore text underscore group is equal to pygame.sprite.group. So just inherit damage text object. Now, just to test it out, let's create a temporary damage text object. So because this is going to be a sprite object, I'm inheriting from the sprite class, I'm going to be using groups again just here. So at the moment, the constructor doesn't have anything in it. Now, although we've got the arrow actually take small, which then we create the constructor as normal. So we'll create the init method with just for now the self argument, and then of course because I want this inheritance I want to add in here pygame.sprite.sprite, and we need to add in the init method from the sprite class. So how's this damage text class going to work? Well, essentially it's going to take the number, which is the damage that has been dealt. It will use where I'm going how much damage has been dealt. So we'll add the damage variable, and then lastly, I'm going to add the color variable here. So what color do I want to display this in? So now that I have these, I need to make sure that I assign them to the class. So say self.image is equal to, well, like I said, I'm going to take this damage variable and turn it into an image on this window. Now I'll go back, I'm going to be using beneath these movement. So that's going to be, let's give it a structure you want to use fonts to an image. There's a few arguments. So the first argument is how much, or rather what is being converted. Then the second argument we set to true, and the third argument is what color we want this to. So self.rect is self.image. All of these arguments now used up. So for now, this is all the functionality that I want. And it we'll build up on it a little bit more, and that means we need to create an instance of it. Now those actually work. It's going to be our class. I'm going to be using so because create a temp temporary a sprite object I'm inheriting from the sprite class. I'm going to be using groups again, just like I did with the arrows. So just before the arrows here, I'm going to say damage underscore text underscore group is equal to pygame.sprite.group. And now let's just create, so I'll make a big section here so I can easily find it later to delete it. And I'll just say temporary damage text. So we'll just put this on the screen, we'll just create it so that we can test it's working correctly. And I'll just say damage text is equal to, it's an instance of the damage text class. I need to give it the arguments that it was asking for. First of all was the xcore damage, and an update and a draw method. So we can just go back down into the main game, just underneath that, but not indented, so it's not going to be within the for loop, it's outside of it, where you can say damage text group dot update, and then down here we can say damage text group dot draw onto the screen. Okay, so let's just test if this works. We'll run this, and I've made a typo somewhere. Of course, I was putting that together a little bit too quickly. So within this section here where I render the text to an image, well, this needs to be a string, but of course I've just passed it a number. So it shouldn't be a number of 15, it should be a string that says 15. So let's try that again. Okay, there we go, and there's a damage text. So of course it's not positioned anywhere near the enemy where it should be, but it's positioned where we specified. So the X and Y coordinates, the number 15, and the color of red. So now we can go back here where we've got this temporary damage text and just delete this. That was just so that we could test it out. We'll get rid of that. And now we can set up a way of actually creating these damage texts correctly. So whenever the arrow hits the enemy, we create one of these damage texts. Well, that's going to be handled within the weapons module and the arrow class, because this is where we're doing that collision check. This is where we're checking whether the arrow has made contact with one of the enemies. And here is where we're calculating the damage. So this is what we're going to want to display on the screen. That means that we want to take this variable from here and return it back into our main game loop where the damage text class is. So we just need to add a return statement to this this update method. So we'll just say here return damage. But remember, if we want to return something, we need to make sure that it is defined before we try this, otherwise we'll have an error. Now this damage is not automatically going to be defined every time because there's not going to be a collision instantly. So at the very start of the update method, we want to add a little comment to say reset variables, and we define damage here as 0. So at the beginning of each update method, damage is 0. It will return this here, but if this condition is met, well then damage is calculated correctly and it's returned instead. So that takes care of one of the arguments, but if we go back to the damage text class, it actually also takes an X and Y coordinate. That's something else that we're going to have to pass back into it. So the damage text, we want to appear on top of the enemy. So when the arrow hits the enemy, we want this damage text to pop up from the enemy. Well, within this update method of the arrow class, we already are looking through each of the enemies. So it goes to say then that as soon as we've dealt damage to the enemy, we can also work out where that damage should be positioned on the screen, because it's just wherever the enemy is. So here we can say damage underscore pause for position is equal to the enemy rectangle. So enemy.rect. So that's another variable that we can now return. So return damage position, but again, because we're trying to return something that's not already defined, we go up here and make sure that we define it. So damage position is equal to none to begin with. So with that done, because our update method now none to begin with. So with that done, because our update method now returns these two variables, we need to make sure that we're actually taking those variables back in the main game loop. So in the main game loop down here, we are calling the arrow, where is it? Arrow.update here. So we're calling the arrow update method, while we now need to expand this to actually take those variables back from it. And we're passing two variables back, so it's important to keep the order of them the same. So first it's damage, then it's the damage position. So here we need to return them and we need to accept them in the exact same order. So here we'll say damage, comma, damage underscore pause is equal to the arrow's update method. So now we're going to have these two variables populated. So now at every iteration of the arrow or the arrow's update method, we're going to be taking this damage variable back. But most of the time, it's going to just be returning a 0 because that's what's defined up here. The only time it's going to be returning anything other than 0 is if it's made contact. And that's the point at which we want to create this damage text. So that means that here, once we take these variables back, we can then run a quick check on these variables. So underneath here, within this for loop, we're going to add an if statement. So we'll say if damage, so it basically just means if something has been returned within that damage variable that's a non-zero value, well that means we've just hit an enemy with the arrow. So we want to now create a damage text object. So here we can say damage underscore text is equal to damage text, which is the class name. And here we need to give those same variables. So first of all, it's the X and Y coordinates. Well, those we're going to take from this damage pause variable here, which is a rectangle. So for the X coordinate, we'll say damage underscore position dot center X. And then for the Y coordinate, it will be damage underscore position. Now, I don't want to use center Y because I don't want the damage text to appear in the middle of the enemy. I want the damage text to appear kind of just above their head. So that would be the Y variable. And the next thing is the damage itself. So how much damage is done? Well, that's returned here. But remember, as I already made this mistake before, it comes in as an integer, but we need a string. So here we're going to convert it into a string. And then lastly, we need to pass the color. So that's constant.red. So this will create an individual damage text object, but remember we're using groups for this. So we need to make sure that we add this into our group by saying damage text group dot add damage text. Okay, so let's just test this out again before we go too much further. No errors there. Let's hit the send. Okay, so let's just test this out again before we go too much further. No errors there. Let's hit this enemy, and there we go. You can see a little number 9 has much text to our group by saying damage text group dot add damage text. Okay, so let's just type dots for this. So we need to make sure that we add this into our group by saying let's hit each tag. Remember, we're using groups for this. So we need to make sure that we add this into our group by saying, okay, okay, so let's just test this out again before we go too much further. Hits the enemy. Now, although we've got the arrows, I would like arrows to load in all of our images, but before we start creating instances, I'm going to have a little section here where I'm going to add a new class. So this class is quite small, which is why I'm not putting it in a separate module of its own. I'm just going to keep it here within the main file. And this will be the text, so the class. So .sprite, init method, I want to add in here pygame.sprite, and we need to add in the init method from the sprite class. So how's the damage text class going to work? Well, essentially, it's going to take the number, which is the damage that has been dealt. It will turn it into an image and it will blip that image onto the screen for us. So we need to add in a few arguments here. So at the moment the constructor doesn't have anything in it, but first of all I need to know where I'm going to position the damage text. So we'll give it x and y coordinates. We also then want to know how much damage has been dealt. So we'll add a damage variable, and then lastly I'm going to add the color variable here. So what color do I want to display this in? So now that I have these, I need to make sure that I assign them to the class. So we'll say self.image is equal to, well, like I said, I'm going to take this damage variable and turn it into an image. So there's a way of doing this within Pygame. So you can't just take text and display it on the screen, because you notice every time I put print, it goes down here. It doesn't actually come up in the game window. But before we convert that text into an image, we need to first of all define the font that we're going to be using for this. So that's going to be something that will be defined as a variable. Now I'll go back up here. Let's see, where's the best place to put it? We'll just put it underneath these movement variables. So I'll add a section and I'll say define font, or the comment, define font. And the font is going to be equal to pygame.font with a capital F. And then I just need to load it in. So I need to give it the file name and location, just like I've done with all my other assets. So if we go back to the folder structure here again, we have assets, and there's a folder called fonts, and then I have a font that I want to use here. So we just need to navigate through it. We'll say assets /font. The font needs to, I can go back into my, I'm just going to say we'll give it a font size of 20. Now using this font, I can go back into my damage text class, and I can use that font to convert the text into an image. So first we'll say font, then we'll call the render function. And here's a few arguments. So the first argument is how much, or rather, what is the text that I want to display? Well, the text is the damage, so the amount of damage that's being done is being converted. Then the second argument we set to true. And the third argument is what color we want this to be displayed in. Well, that's also being fed in here as an argument, so we'll put in color there. So that'll be the image created, and of course we need to convert, or we need to create a rectangle from it. So self.rect is self.image.get_rect. And then we need to position that rectangle. So self.rect.center is at coordinates x and y. So that's all of these arguments now used up. So for now, this is all the functionality that I want in it. We'll build up on it a little bit more in a second, but let's just see if this actually works. So we've got the class, we'll build up arguments now, rect.center is at, and then we need to position that rectangle. So self.rect.center is at coordinates x and y. So that's all of these arguments now used up. So for now, this is all the functionality that I want in it. We'll build up on it a little bit more in a second, but let's just see if this actually works. So we've got the class created, and that means we need to create an instance of it. Now those are going to be created automatically anytime we shoot an enemy and we make contact, but for now, just test it out, let's create a temporary damage text object. So because this is going to be a sprite object, I'm inheriting from the sprite class, doing that collision check. This is a moment calling the arrow here. Once we take these variables back, so for the x here, we're going 100 to 91 down here. So I wonder if it'll work a second time. Okay, there we go. So we're seeing them kind of stack up on top of each other. So every time we are getting a different amount of damage that's being displayed correctly. Problem, of course, is that they're all just being overridden on top of each other. So what I would like to do is have that text appear and then slowly float up the way away from the enemy. So let's go back up into the damage text class and just add a little bit more functionality to it. So at the moment, all we have is a constructor. So now let's create an update method. Now we're already calling this update method, it's just there isn't one in existence. So we've inherited one from the sprite class, but it's blank, it doesn't have any functionality. So we can override it here by adding the functionality that we want. And all we really want to do is add a comment to say move damage text up, which is going to be achieved by updating the rectangle's y coordinate. So I can say self.rect.y is, well, if it's moving up the way, remember that means that it's decreasing. So it's heading towards 0. So we just decrease it by 1. Okay, and that should be enough. Let's run this again and attack the enemy again. And there you go. So the number appears and it floats away up the way. And if I keep shooting them, the same happens. So now it's a lot better. We're now seeing these numbers kind of float up. But of course, there is still one issue, which is that they just keep going. So they don't really disappear. They just float off the screen endlessly. So what I would like to do is add some kind of counter, and eventually, after a certain amount of time, those bubbles, or sorry, those damage texts just disappear. So within the constructor, let's add a new variable called self.counter, and we'll set that to 0 to begin with. And then within this update method, we'll add another comment down here to say delete the counter after a few seconds. So here we just increase the counter by 1. So we just count up the way. So we say it's increased by 1, and if it reaches a certain value, so if self.counter is greater than, let's say, 30, so I guess it's not actually going to be a few seconds, but doesn't matter. So if self.counter is greater than 30, we just want to get rid of this object. Well, remember, because we've inherited from the sprite class, we have that self.kill functionality. So we'll say self.kill, and that's going to delete this text. So I'll run this again and shoot this guy, and there we go. So it appears for just, I don't know, just for a little bit, and then it disappears. So that's a lot better than, they don't really stack up on top of each other as bad. badly and they don't just keep floating off endlessly. So for now, we're done with this damage text class, and I'm going to see if I can hide it just to tidy things up a little bit. We'll return to it to add a little bit more functionality later on, but for the time being, that's all that's needed for it. In the previous section, we added this damage text class to show how much damage is being done to the enemies. Well, what about the player? So I don't want to show how much damage is being done to the player. Instead, what I'm going to do is track how much health the player has and just show it on the screen. And for that, I'm going to be using little heart images. So these heart images I can show you. They're in this assets, images, and items folder. And I've got 3 different ones. So I've got this, well, I don't know if you can see that actually, but a full heart, and then half a heart, and then an empty heart. So if we go back into this main file, before I can actually use these images, I need to make sure that they're loaded in. So we'll do that first. So let's just put them up here before we load in our weapon images. I'll have a section to say load heart images. And there's going to be 3 of them as I just showed, so I have to have 3 different variables. So say heart underscore empty is equal to, so this is, in fact, I'm just going to copy it from here to save me typing it all out again. It's essentially the same code. So I'm going to be scaling the image, but first of all, I need to load that image. So the image that I'm loading is in folder of assets, images, then it's items. So I need to update this bit here. And then the name of the file is heart. Is it empty? Yes, heart. But first of all, I need to load that image. So the image that I'm loading is in folder of assets, images, then it's items. So I need to update this bit here. And then the name of the file is heart. Is it empty? Yes. Heart empty. So we change this last bit here as well. Heart underscore empty dot png. And then lastly, I need to update the scale. So I'm not going to use a weapon scale. I will have a new variable called item scale. So let's just put it in here under weapon scale. So item, oops, should be all caps, item underscore scale. And we'll go with 3, just so similar to the global scale, but we'll keep it specific to the item. So item scale is also 3. So I just need to remember to update it in here, change this from weapon to item scale. So that's 1 image loaded in. I just need to repeat this for the other 3. So I'm just going to copy this down and paste this a couple more times. And we'll go with 3, just so similar to the global scale, but we'll keep it specific to the item. So item scale is also 3. So I just need to remember to update it in here, change this from weapon to item scale. So that's 1 image loaded in. I just need to repeat this for the other 3. So I'm just going to copy this down and paste this a couple more times. And now I just need to update the file names. So the second one is going to be heart half. So we change this here as well to half. And then the last one is going to be full. So I'll change both of these to full. Now to display these heart images, I'm actually going to create a separate function, and this function is going to capture, as the project goes on, it's going to capture additional information. So for now, it's just going to show hearts, but eventually I'll add the level number and so on into it. So let's just go down here. So after we've loaded all of our images, but before we create this damage text class, let's create a function here. I'll add a comment first of all. I'll say function for displaying game info. So we'll define draw underscore info, and we'll add a little comment here to say draw lives. And here we're going to have to figure out how these lives or how these hearts are going to be assigned. So the player is going to have 100 health to begin with. So if I say I pick 5 hearts to draw, and that's going to represent 100 health, well, that means that each heart is worth 20 health. And because I can draw half hearts, a half heart is 10 health. So if I'm going to draw 5 hearts in total, then I need a for loop. So I'll say for I in range 5. And now at each iteration, this I variable is going to change. So we're going to have to work out whether that heart is going to be a full heart, an empty heart, or half a heart. So we'll put an if statement here, and we'll say if player health, so we basically need to be comparing how much health the player has against this I variable, is greater than or equal to, and we'll put double brackets here, I plus 1 multiplied by 20. So that one maybe doesn't make much sense, so I'll just explain what's going on here. Now I've already defined that a heart or a full heart means 20 health. So that's what this multiplied by 20 here is. And we know that a for loop will, if we're given a range, will begin at 0. So on the first iteration, this I variable is going to be 0. So basically I'm trying to check whether that first heart should be shown as a full heart or not. Well, let's say the player has 10 health. So if player health is 10, let's just write this underneath. So we're basically saying if 10 is greater than or equal to. So if the player health is 10, then it shouldn't be a full heart, because a full heart is 20 health. It should only be a half heart. So this condition needs to be false. Well, let's see if that's the case. So if 10 is greater than or equal to, I at this point is going to be 0. So I plus 1 is 0 plus 1, so it's 1. 1 multiplied by 20 is 20. So this condition is not going to be met. So it means that if we only have 10 health, we're not going to draw a full heart. Well, let's say we have 20 health. That should be a full heart. And this condition will be met. So we can get rid of this and say that at this point, if that if statement is true, then we want to show a full heart on the screen. So we can say screen.blit. The image we want to blit is heart underscore full. And then we need to give the X and Y coordinates. So the X coordinate is going to be controlled again by this I variable, because each heart is going to be moving along from one to the next. So we want to space them out based on the I variable. So we'll say I multiplied by 50, so it'll be 50 pixels apart for each heart. But we also don't want it to be right up against the left hand side of the screen. So we kind of want to offset it by 10 pixels to begin with. So it'll be 10 plus I multiplied by 50. And then the Y coordinate is just going to be 0, so it's shown near the top of the screen. So let's just test this out as it is for now before we add in half hearts and empty hearts. So we'll go down into the main game loop and go to the section where we're drawing everything. And actually I can get rid of this enemy health part. So we're drawing the draw damage text here. So just underneath we'll call that function. So we'll say draw underscore info. Okay, let's run this and just see if it works. Okay, so it's worked. So we've got these 5 hearts at the top. Now, of course, that's working correctly because the player does have 100 health. But if I start dropping the health, let's see how it affects things. So the health is controlled by this variable here. So let's just drop it to 80. So now I've dropped a heart. So I've gone down to 4 hearts, which is correct. Now if I had 90, what would happen? Run this again. Well, it's still semi-correct, right? It's still showing 4 full hearts. It's just not, what it should be showing is half a heart at the end here. Now let's drop it down to 20. So that's given us our full heart. It should also show 4 empty hearts. We just haven't coded that part in yet. And what if we go down to 10? And 10 gets rid of them entirely. So we know that the full hearts part of it is working, but the half hearts and the empty hearts isn't working yet. So let's add that in. Let's put this back to 100 just for now. And go back into this draw info function. Where's it gone? Here. So the next one we want to do is half hearts. So let's add an elif statement here. So essentially, if this condition is not met, then that means we're not going to draw a full heart. Well, then we need to see if it's going to be a half heart or no heart, or like an empty heart. So a half heart is going to be anywhere between, say, 20 or 40 or 60, between those big round numbers of multiples of 20. So if we have, say, 23 health, then it would be 1 full heart and then 1 half heart. So essentially, to work out if we need a half heart, it would be whether or not we have a remainder by dividing by 20. So if I have 40 health, divide that by 20, there's no remainder. It just divides into 2. But if we have 43 health, we divide that by 20, it gives us 2 with a remainder of 3. So that's all I need to check for. I need to see if dividing by 20 it gives me a remainder, and if I do get a remainder, then that means I need to show a half heart. Well, to check for a remainder, we can just use the modulo operator. So we take the player health, we divide that by 20 with the modulo operator, so the percentage sign, and it's essentially, that's going to give us the remainder. So if there is a remainder, so if it's greater than 0, then we want to draw this half heart. So we can copy this down and just replace the image. So instead of heart full, it's going to be heart half. The positioning is all going to be the same because we're still iterating through this for loop. So this I variable is still increasing and we're moving on to the next point within that table. So let's see how this works. Now we have 100 health at the moment, so we've got 5 hearts. Let's drop this to, let's even drop it to 99. What do we get there? Okay, so we let's even drop it to 99. What do we get there? Okay, so we've got 4 full hearts and then a half heart. So it looks like it's working, but if we play around with these numbers, say drop it to 75, we now get 2 half hearts because the condition is met twice. So this first if statement is met 3 times, but then this second elif statement is met twice. So we end up with 2 half hearts, which we obviously shouldn't. So what I need to do is add a little trigger in here. Basically, a little counter to say that I can only show 1 half heart. Anything after that needs to be just an empty heart. So underneath here, we will have variable called half underscore heart underscore drawn and set that to false to begin with. And then I can add that as an extra condition into this elif statement. So if that condition is met and half heart drawn is false, then we will draw that half heart, but then we will set that variable to true because we've now drawn it. So we don't want to draw another one. Okay, so now let's test this again. So at 100 health, we have 5 hearts. At 90 health, we have 4.5. But what happens at 70? Okay, well that's kind of worked, right? We've got 3 full hearts, a half heart. We're just missing the empty heart at the end. So that's the only bit that we need to add. So if none of these conditions are met, these if and elif statements, then we just add an else. So else, we don't need to do any more checks. Whatever's left over is just going to be these empty hearts. So we replace that with empty. Okay, so we'll run that again with 70 health, and there we go. So that's full, so that's 20. Okay, so we'll run that again with, so we'll replace that with empty. Okay, so we'll run that again with 70 health, and there we go. So that's full, so that's 20, 40, 60, half a heart, and then an empty heart. Let's drop this down to, say, 10. We've got half a heart and then a whole bunch of empty ones. And back to 100, and then we got 5 full ones. Now, I would just like to tidy this up a little bit, because at the moment, although this is showing the hearts correctly, when we eventually build up the level and everything else, it's going to be a bit of a conflict here, because these hearts are going to be drawn over whatever's underneath them. What I actually want to do is add a little panel at the top of the screen to separate the game area down here from this little info area at the top. So first of all, let's create a color that we're going to define, that we're going to use for this little panel, this info panel. So we go into the constant section, and we've got red, we've got background. So let's say panel is equal to, and we'll set this to, let's just try 50, 50, 50. So we go back into this function here, this draw info function. And before I even draw any of these hearts, I'm going to first of all draw that little panel. So that's going to be done with 2 lines. The first line is I want to draw a rectangle across the top section of the screen. So I just say pygame.draw.rect. It's going onto the screen. Then I need to give it a color. Well, I've just defined that color as constants.panel. Then after that, actually that doesn't need to be in a bracket. Get rid of that bracket there. So then the next argument is going to be the rectangle itself. So essentially the start and end point, the start point and the width and the height. So we're going to draw this from the top left corner. So X and Y coordinates are 0, 0. It's going to go across the entire width of the screen. So the width is going to be constants.screen width. And then the height, I'll just set to 50 pixels. So let's see how that looks. There we go. Okay, so you can now see a much clearer division between this panel and the game area. But just to highlight it extra, I'm going to add a little line at the bottom of it as well. So we're going to say pygame.draw.line. And again, it's going onto the screen. The color is going to be constant. Now, have I defined a white color? Not yet. So let's define a color of white. Just to give us more of a contrast there. So that's 255, 255, and 255. So it's constants.white. So that's our color. And now I need to give 2 coordinates here. So the first is going to be the start coordinate. So this line is going to start at x coordinate 0, y coordinate 50, because remember that's how tall our panel is. And in the end coordinate, well, it just spans the width again, so constants.screen width, and height stays at 50. So let's run that again, and there you go. There's that white line going across, and that definitely highlights the division between the two areas. So we're going to come back to highlights. So let's run that again. Our panel is, and in the end coordinate, well, it just spans the width again, so constants.screen width, and height stays at 50. So let's run that again, and there you go. Screen width, and height stays at 50. So let's run that again, and there you go. There's that white line going across, and that definitely highlights the division between the two areas. So we're going to come back to this draw info function later down the line, because as I said, there is going to be more information that I want to show here. You've noticed that I've left quite a bit of space here, but for now we're done with it. So now what I'd like to add in is some items for the player to collect. So we already have this